Very good evening, all my dear students. How is everyone? Welcome to all of you to yours Unacademy NEET English channel. Hey kids, today we are going to start with the awesome topic. What's the name of the topic? You know from the thumbnail. Yes, that's optical isomerism. If I talk about optical isomerism, number of things are there which you don't know. If I say that, okay, let me tell you each and everything one by one. But before that, everyone do let me know, can you hear me? Can you see me? If yes, you know the drill. Hello, Akanksha Singh, Srinath, very good evening. Very good evening. Very good evening to Priyanka, Vedjani, Trisha, Apu, Ramakant. My all dear friends, I welcome to all of you to this fabulous, awesome topic that holds a whole lot of weightage in your organic chemistry. Not only in organic chemistry, it is also very, very important in your inorganic chemistry. If I talk about coordination chemistry, this chapter holds a whole lot of weightage. So, if we know about optical isomerism, number of things we are going to cover it up. So it's really very, very important. So how is everyone? Introduction of isomerism. Apu J, in the starting, I have explained structural isomerism and geometrical isomerism. Two topics in detail I have already told you. If you see the previous lectures, isomerism I have told you, but yes, introduction of isomerism I will tell you today. But let me tell you that optical isomerism is really very, very important, and number of things are there which you actually don't know, and number of times you are going to get wrong answer. Before I start, I want to see in the chat section green signal, the fire, Priya Birma, killer science, everyone is here. So before I start this awesome chapter, I want to see some Josh in the chat section. Muhammad, Ramzan, everyone is there. I want to see some Josh in the chat section for your HSP Baba. I have been teaching for last 23 plus years and produced number of ranks, top 10, all the ranks you can say in mass selection. So kids, today, yes, the most awaited topic on everyone's demand, I'm going to start. Yeah, I have seen Arti is there, Dishari is there, Akanksha is there, Ravina is there, Man is there, everyone is there. So let me start. If you're new to this channel, subscribe this channel, and others hit the like buttons. Likes are very, very less. It's yours channel. Kids, what are you doing? It's yours own channel. Hit the like buttons and show me your presence. I need attendance, wherever you are in school, class 1, 2, 3, 4. So Ramu, yes sir, present. Shamu, yes sir, present. That attendance, everyone mark that attendance, yes. So let me start. If I talk about optical isomerism, kids, optical isomerism. This optical isomerism is really very, very important. And if I ask one question, kids, for optical isomerism, what is the necessary condition? Is there anyone who is going to let me know what is the one and only one necessary condition for a compound to be optically active? Yes, this is my question to each and everyone, and let me know necessary condition. Let's see who is going to give me the answer. Necessary condition for a compound to be optically active. For a compound to be optically active. Yes, I want to see in the chat section I want to see the chat section, the answer. Chiral carbon, chiral center. Everyone is writing chiral carbon, chiral center. So kids, let me tell you answer of this question. Chiral carbon is not the necessary condition. Chiral carbon, if your answer is chiral carbon, then examiner will give you 0 marks. Kids, this is not the necessary condition. If you're writing chiral carbon is the necessary condition, your examiner will give you 0 marks. 0 marks. This is not the necessary condition. Now you will say, sir, what is this? You are saying that chiral carbon is not the necessary condition. Yes, chiral carbon is not the necessary condition. If you're writing this thing, your examiner will give you 0 marks. So what is the necessary condition? Let me tell you. And that's why this lecture is very, very important for each and everyone. So for a compound to be optically active, for a compound to be optically active, compound should not have element of symmetry, that is plane of symmetry and center of symmetry. Compound shouldn't have pos and cos. Compound should not have pos and cos. Shouldn't have. Pos and cos should not be present. That means neither plane of symmetry nor center of symmetry. Compound can have chiral carbon or cannot have chiral carbon, but that is not the necessary condition. Compound should not have plane of symmetry and center of symmetry. If compound is not having plane of symmetry and center of symmetry, then also the compound can be optically active. So, what are you talking about? Yes, I'm absolutely correct. Let me tell you. This is the thing which I'm going to tell you, kids. If I say a compound is having chiral carbon, having chiral carbons. What I have written? A compound is having chiral carbons. Underline it. A compound is having chiral carbons, but this compound is not having. But if this compound not having what? Not having pos and cos, then what will you say? It's a compound is having chiral carbons, but if this compound is not having, pos and cos, then what will you say? This compound is optically active or optically inactive? What will you say? What will you say? This compound is optically active or inactive? Definitely this compound will be optically active. This compound will be optically active. Now, question arises how to find out plane of symmetry and center of symmetry. Let me tell you, plane of symmetry is 99% important for NEET examination, but center of symmetry is very, very less important. So are you ready? For plane of symmetry and center of symmetry? What I said, plane of symmetry's importance is 99% important, because we should know very well that what is important and what is not important. Just getting knowledge is not everything. We should have to get the best rank. So remember that plane of symmetry is 99% important, and center of symmetry for your examination is just 1% important. So where you have to focus more, which point you have to focus more, where you have to put your maximum focus, plane of symmetry. So this is the thing which is very, very important for your examination. So we have to understand plane of symmetry. Everyone, Yuvarajan, good evening, good evening, good evening, good evening. So everyone hit the like button. So are you ready? Now kids, if you want to get 100% marks, then you have to understand plane of symmetry in detail. If you want to get command in coordination chemistry, that is a portion of inorganic chemistry, then you have to understand plane of symmetry. So is everyone ready for plane of symmetry now? Let's see. What is plane of symmetry? Let me tell you what is this plane of symmetry. Let me write down the definition of plane of symmetry. Plane of symmetry is an imaginary plane, which divides the whole compound, which divides the whole compound in two equal parts, so that one part is the exact mirror image of second part. Now kids, let me give you some examples of it, but before that, do let me know everyone, you just take your hand, either right hand or left hand. So better to take your right hand, okay? And you're not supposed to cut it. Don't take knife and start cutting. No, imaginary plane. See, it is an imaginary plane. Imagine, just you have to imagine, right? Imaginary plane. So just try to imagine from where you have to cut it so that it could divide in two equal parts. Is there any way? Either you cut from here, this side is the thumb and that side thumb is not there. See, you cut it like this, you won't be able to divide in two equal parts. And if you divide it like this, then this is the rough surface and this is the smooth surface. You won't be able to divide this hand, isn't it? Vidya, Pravalika. So is there any special session for isomerism? Vidya, I have taken isomerism, structural isomerism. I took geometrical isomerism, and this is the most important topic, that is optical isomerism. Later on you can see that, you can watch that. Okay, you can watch that later on, right? Now, so this hand is optically active, right? Now, let me draw over here and let me tell you. See, if I draw this A, do let me know everyone. If I draw this A, is there any plane of symmetry? Do let me know everyone. Is there plane of symmetry? Yes, answer is yes, there is plane of symmetry. Which one? This is the plane of symmetry. You can see this is known as vertical plane of symmetry. This, if I divide from here, this line is dividing this part and this part. This part is just the mirror image of that part. So this is known as vertical plane of symmetry. Everyone, This is known as vertical plane of symmetry. So this compound can't be optically active. Now suppose if I draw this compound, do let me know everyone, is this compound having plane of symmetry? Do let me know. Is this compound having plane of symmetry? Everyone do let me know. Is this compound having plane of symmetry? Yes. The answer is yes. If I divide it from here, this is known as horizontal plane of symmetry. This is known as horizontal plane of symmetry. Horizontal plane of symmetry. So these two compounds are optically inactive because they are having plane of symmetry. These two compounds are having plane of symmetry. So these two compounds are what? Optically inactive. Now you will say, and you will ask, sir, these are A, B, C, D. Don't tell us in this. Just let us know in organic compound. Take an example of organic compound. Let me take example of organic compound. See, if I take these examples, CH4, CH3Cl, CH2Cl2, and C fluorine, chlorine, bromine, iodine. So how many compounds? 1, 2, 3, 4. I took 4 compounds. 1, 2, 3, 4. Now, if your visualization is very good, you can do anything, kids. You can understand anything. So let's visualize it. You won't be able to visualize it like this. Let me take 4 pens. Let me take help of 4 pens. Let me bring it. Just give me 30 seconds. Let me bring it. Okay. 30 seconds. Just give me 30 seconds. So kids, I'm back with the number of pens. So if I take this black, 1, 2, 3, and 4 black. Let us suppose if I am going to draw CH4. So this carbon is holding 4 hydrogen atoms tetrahedrally. Okay. Now see, this is carbon. Let us suppose carbon, and if I draw this angle, this is 90 degree. So let me make it like this. Let us suppose this is 109 degree. Okay. 1V. As you visualize tetrahedral, the visualization will give you the best command on this stereochemistry. This is 1V, right? Carbon, 1 hydrogen, another hydrogen, 2 hydrogen atoms. Now, let us suppose this another V is bisecting this V. This V is bisected by this V. You can see these 2 hydrogens. Can you see? This is the structure given by Lee von Thorp. You must have studied in class 9th. leave on top like this. Actually, it is like this. Can you see? Or you can see like this. You can visualize it like this. Whatever the way you want to visualize, you can visualize. Now see, if I'm keeping it like this, that all are being hydrogens, all the 4 atoms are same, right? All the 4 atoms are same. And if you divide it like this, see, if you divide it like this from that side, let me bring near to you, and if you divide it like from here, the pen, half of the pen will go towards right hand side, half of the pen will go left hand side, as the hydrogen atoms are spherical. You can see now, once you are going to come over here, this is also hydrogen on right hand side, and this is also hydrogen on left hand side, and this is once again hydrogen. Can you see? This is plane of symmetry. If you are going to bisect it, you are getting the plane of symmetry. Everyone, do let me know. Can you see the plane of symmetry is there? So all the 4 atoms are same. The plane of symmetry is there. Just do let me know by the thumbs up that if everyone is able to understand, because otherwise the difficulty will means increasing, right? Do let me know that everyone is able to understand. Just show me the thumbs up. So now let me take the example of methyl chloride. 3 atoms are same, 1 atom is being different. Let me change 1 atom. This is chlorine. 1 atom is being different. So I have changed just 1 atom. Rest of the 3 atoms are remaining same. I've just changed 1 atom. You can see this atom has been changed. Can you see? Now if I divide, just apply your brain. Everyone apply your brain. Let me check it out whether your mind is working or not, brain is working or not. If I cut it like this, this green pen will go half on the right hand side and half on the left hand side. This is hydrogen, and this is once again hydrogen. So it is also having plane of symmetry. So everyone is able to understand that this compound is having plane of symmetry. Here plane of symmetry is present. In this plane of symmetry is present. So these 2 are optically inactive. Now this is having 2 hydrogen, 2 chlorine. So 2 atoms are different. Let me change this atom also. So let us suppose these 2. So these 2 are hydrogen atoms. These 2 are same hydrogen atoms, and these 2 are chlorine atoms. Just see, these are having 2 chlorine atoms. So let me put chlorine here. Let me put chlorine over here. See, now apply your brain. Again, I'm not going to tell you. If again and again I'm going to tell you, you won't be able to understand. Kids, do let me know. If you cut it from here, the blue half portion will go on the right hand side and half portion will go on the left hand side. Now this carbon in the middle, half on the right hand side, half on the left hand side. This hydrogen is already on the right hand side and left hand side, and this is also chlorine, right hand side, left hand side. Is the plane of symmetry present or not in this? So you can see here also plane of symmetry is present. Plane of symmetry is present. Now let's see the 4th atom. Everyone is ready for the 4th atom, that all the 4 atoms are different. Fluorine, chlorine, bromine, iodine. This carbon is holding all 4 different atoms. Now see, if I change color of all 4, so see, this is white, this is black, this is blue, and let me change the color of this pen also. This is being green, this is being green. Can you see? All 4 atoms are totally different. Okay, see, all 4 are totally different, everyone. Now if I make this V with black and white, this is black and white, and this is green coming towards your side, and this blue is coming toward this side. You can see 3D in the 3D figure. This is being carbon attached with 4 different atoms or group. Just see to it, everyone, see to it. Now you cut this green. Oh, half of the green has gone right hand side, half of the green has gone left hand side. Wow, so nice. Now, once you are coming to carbon, carbon half will go on the right hand side, half left hand side. But here is white, here is black. They are different. So no plane of symmetry. You can see here the plane of symmetry is not present because there is white, there is black. Here it was present, see, green and blue. Now you will say, sir, let me do one thing. I will start cutting like this. I will start cutting like this. The white was the problem. It was creating the problem. Half of the white will go toward this side, half will come toward this side, and black half that side, this side. But see, this side is green and here is blue. Once again, the plane of symmetry is not there. You just see to it. If you're going to cut it from here, that half of the white will come toward this side, half will go toward that side. And if you're coming in the middle, here is the plane of symmetry, but this is green and this is blue. The plane of symmetry is not present. Can you see, kids? Wherever you want to cut, you will say, let's see, sir, this blue was creating problem. Let's cut it from here. The blue half will go toward that side, blue half will come toward this side. But see, that side is green and this side you can see is black. Black is there. Can you see, everyone? Are you able to visualize? So I think everyone got it, that if any compound is having one carbon, only one carbon attached with 4 different atoms or group. If compound is having only one chiral carbon. What is chiral carbon? I will let you know, but let me complete this. If compound is having only one chiral carbon, then no cause. That compound will not have pause and cause. No pause, no cause, and compound will always be optically active. Compound will always be optically active. Compound will always be optically active. Now I'm going to tell you what is chiral carbon. But before that, one question must be arising to your brain, that, sir, earlier you said that chiral carbon is not the necessary condition for a compound to be optically active. Now, once you said that thing and you are talking about chiral carbon only, see, I will let you know what's the difference in the concept. See, first let me tell you, if carbon is attached with 4 different atoms or groups. 4 different atoms or groups. These 4 different atoms or groups should be according to CIP rule. 4 different atoms or groups must be according to CIP rule. According to CIP rule. If carbon is attached with 4 different atoms or groups according to CIP rule, then carbon is known as chiral carbon or chiral carbon or asymmetric carbon. Now, when the compound is having just one chiral carbon, let me tell you, these statements may come as assertion and reasoning. These are the killer points where students are getting negative marks. See, kids, if compound is having just one chiral carbon, just one chiral carbon, it will never have pos cos. It will never have pos and cos, and it will always be optically active, will always be optically active, and will always be optically active. And that's why in your examination you must have studied. If I talk about examination, that's class 11th and 12th, you have been taught only about chiral carbon, and all the questions you are getting full marks, because up to class 11th 12th, if any teacher is just talking about one chiral carbon, so one chiral carbon, then the compound will always be optically active, because it will never have pos and cos. But what I would like to say, you are going to prepare for competitive exam, you are going to get more than 700 marks, 600 marks. So you should know, if compound is having more than one chiral carbon, more than one chiral carbons, then two possibilities are there. Then two possibilities are there, kids. Two possibilities are there. What are these two possibilities? If compound is having pos cos, either pos or cos, compound is having pos or cos or both, then compound will be declared as optically inactive. Then compound will be optically inactive. And second condition, if I talk about second condition, if compound is neither having pos, nor cos, then the compound will be optically active. Then the compound will be optically active. So what is important thing? Then compound will be optically active. Now kids, are you okay, or you started feeling headache? Because these are the genuine points. What I want to say, that if any compound is having what? Plane of symmetry or center of symmetry, then the compound can never be optically active. So is it possible that compound should have pos cos without chiral carbon? Yes, let me tell you. There are number of compounds, kids. There are number of compounds. There are number of, no, I will not write like this, otherwise you will say no. There are number of compounds which do not have chiral carbon, which do not have any chiral carbon, There are number of compounds which do not have any chiral carbon, but they are optically active. Now, what's the reason? This is the assertion. This assertion is absolutely true, 100% correct. Now, there are number of compounds which do not have any chiral carbon. Let me underline it. Want to be noted, my lord, which do not have any chiral carbon. The number of compounds which do not have any chiral carbon, but they are optically active. This statement is true or false? Everyone will say false, or 99% people will say false, but this is absolutely true. 100% this is true. And the reason is, let us suppose this is the assertion. This assertion is 100% true. So reason is, what's the reason for it? Reason is because they do not have, because they don't have plane of symmetry and center of symmetry. This is the reason. So what is important? Chiral carbon is important, or plane of symmetry, center of symmetry. This is important. So remember that. Now I'm going to deal with another term. Now kids, you must be thinking like that. So when we have studied on different YouTube channels, we are thinking like that, we will move like this and that. Kids, this is hardcore. I'm not going to move like in that way, so that you should get number of things, misconceptions. You will feel easy in that way, but you won't be able to get command. Just to let me know everyone able to understand. Now, let me tell you one more thing, important thing. Compounds which don't have pos and cos are known as asymmetric compounds. They are also known as desymmetric compounds. And let me tell you, they are also known as chiral compounds. Now kids, try to understand this point. This holds a hell lot of weightage. What is this? Who is chiral carbon? A carbon which is attached with 4 different atoms or groups is known as chiral carbon. But who is chiral compound? So, what do you think? Chiral carbon and chiral compounds are same? No, not at all. No way. Chiral carbon and chiral compounds, they are totally different. Let me tell you. A chiral compound, can be chiral. A compound can be chiral with or without chiral carbon. See the statement. The statement holds a whole lot of weightage. Really, those students, those who don't know anything, even the ABCD, they will say what the lecture is, what type of lecture it is. But those who are having knowledge, or those who want to gain knowledge, actual knowledge, really it holds a whole lot of weightage. What I'm writing, a compound can be chiral with or without chiral carbon. This line is indicating, one line is indicating the whole hardcore of optical isomerism. This line is very, very important, kids. Very, very important. A compound can be chiral with or without chiral carbon. So chiral carbon is one thing and compound's chirality is another thing. That means chiral carbon is not the necessary condition for a compound to be chiral. Sorry, you got it? Now got it. Now let me tell you about the plane of symmetry. See, everyone see. So let's do some questions. But before doing those questions, if I'm going to deal with chiral carbon, I must have to tell you CIP rule, because number of students will be there, those who don't know anything about CIP rule. So, but before moving towards CIP rule, let me tell you kids, the plane of symmetry in cyclic compound. See, this is a cyclic compound. Do let me know. Is this compound, this is cyclobutane, is this compound having any plane of symmetry? Answer is yes. This compound is having plane of symmetry. If I divide this compound like this is vertical plane of symmetry. If I divide this compound like this, it is having horizontal plane of symmetry. And if I divide this compound like this, this is diagonal plane of symmetry. It is having number of plane of symmetry. So before moving ahead, we should understand what is vertical plane of symmetry, horizontal plane of symmetry, and center of symmetry. This is horizontal plane of symmetry. Horizontal, pause. What is horizontal plane of symmetry? If I take one box, let us suppose if I take this cup and if I cut it like this, see, if I cut it like this, so this is vertical plane of symmetry. You can see this is vertical plane of symmetry. This is vertical plane of symmetry. Vertical plane of symmetry. This is horizontal. Let me tell you horizontal plane of symmetry. Wait. If I take this mobile, and if I cut it like this, right? Horizontal plane of symmetry. And this is diagonal plane of symmetry. Diagonal plane of symmetry. Diagonal plane of symmetry. Everyone, are you able to understand? Diagonal plane of symmetry. That means if I cut this board, suppose this board is on that side also same, then this is vertical plane of symmetry, horizontal plane of symmetry, and diagonal plane of symmetry. Is everyone able to understand? Is everyone able to understand? Now see kids. Everyone see. Let me tell you with the example, otherwise you won't be able to understand. See kids. If I take this box, you see this box. Now, if I cut it like this, vertical plane of symmetry, vertical plane of symmetry. If I cut it like this, see, if I cut it like this, horizontal plane of symmetry, and if I cut it like this, see, cut it like this, diagonal plane of symmetry. You see, this is being NCERT. It is like this. If I cut it like this is diagonal plane of symmetry. Can you see diagonal plane of symmetry? Diagonal plane of symmetry. Can you see diagonally? Everyone. Now see, if I draw one compound, see everyone see to it. If I draw this compound, is this compound having plane of symmetry? Yes, this compound is having plane of symmetry. And the same compound, if I am going to draw over here, the same compound, if I draw over here, and just try to understand kids, if I place here something like this, and if I write down here chlorine atom, and here also chlorine atom, hydrogen atom. Now do let me know everyone, is this compound having plane of symmetry? Do let me know if you are able to understand. Do let me know that yes sir, this compound is having any plane of symmetry. Everyone do let me know kids. If you are able to understand, do let me know. Is this compound having plane of symmetry? This is chlorine, this is hydrogen, this is chlorine, and this is hydrogen atom. See everyone, do let me know. Are you able to understand? Is this compound having plane of symmetry? Yes, this compound is having plane of symmetry. What type of plane of symmetry? Do let me know everyone. Everyone do let me know. Everyone do let me know. Which plane of symmetry? If you are able to understand, do let me know which plane of symmetry. Vertical, no Priyanka, vertical, not vertical. It is having diagonal plane of symmetry. See, it is having diagonal plane of symmetry. If you are going to cut it like this, this compound is having diagonal plane of symmetry. See, this compound is having diagonal plane of symmetry. If you cut it in this way, then two equal parts it will be going to divide. Diagonal plane of symmetry it is having. It is having diagonal plane of symmetry, diagonal plane of symmetry. So this compound can't be optically active. Let me draw another compound. See to it. Everyone see to it. I'm going to draw another compound. Cl. What do you think? This compound is having plane of symmetry. Do let me know, everyone. Is this compound having plane of symmetry? This compound is just like this. Either you can draw it like this or you can draw it like this. Both the way it is the same compound. You can draw it like that. You can draw it like this. Both the compounds are being same. Or you can draw it like this also. Even you can draw it like this also. All the compounds are being same. All the compounds are being same. You can draw it like this also. All these are being same. Chlorine, chlorine, hydrogen, hydrogen. Do let me know, all three compounds are identical. All three are identical. What type of plane of symmetry is there? So definitely you can cut it like this. In this compound, I will say vertical plane of symmetry. Yes, it is having vertical plane of symmetry. Your answer is absolutely correct. This compound is having vertical plane of symmetry. This compound is also having vertical plane of symmetry. And this compound is having horizontal plane of symmetry. So all three compounds are having plane of symmetry. I hope that everyone is able to understand that all these compounds are having plane of symmetry, so they are optically inactive. Plane of symmetry is present, so they are optically inactive. Now, this was the visualization way. Now let's come to the theoretical way. Are you ready, everyone? Two chlorine atoms. Yes, two chlorine atoms are there. Definitely two chlorine atoms are there. And okay, this is wrong, just by chance. So let me rub it. This should be hydrogen. Thank you. Thank you. It should be hydrogen. Thank you. Now see, kids. Let me give you one well-known example that you know very well. This compound is known as tartaric acid. This compound is known as tartaric acid. Just see to it. This is known as tartaric acid. Tartaric acid. H O H O H H O H C O O H. You must have heard the name. Have you heard the name tartaric acid? The compound's name is tartaric acid. Now, if you don't know CIP rule, let me tell you, this compound is having two chiral carbons. This compound is having two chiral carbons. This is one chiral carbon, because right now you don't know what are chiral carbons, what is CIP rule. I'm going to let you know what is CIP rule. Just wait. This is having two chiral carbons, but along with two chiral carbons, you can see very well this compound is having what? This compound is having what? This compound is having its plane of symmetry. You can see very well that this compound is having plane of symmetry. This plane of symmetry is dividing the whole compound in two equal parts. Just see to it. This plane of symmetry is dividing the whole compound in two equal parts. That this compound has been divided in two equal parts. Kids, can you see and do let me know, everyone, if you can see that this compound is divided in two equal parts. So this is having plane of symmetry in spite of having, although it was having two chiral carbons, but due to this plane of symmetry, this is optically inactive compound. This tartaric acid is having two chiral carbons, but then also it is optically inactive. What's the reason? But then also it is optically inactive. Why? Why, kids? This tartaric acid is having two chiral carbons, but although it is having two chiral carbons, it is optically inactive. What's the reason? Plane of symmetry is present. So reason is being plane of symmetry. Plane of symmetry is present, and that's why this compound has been declared to be optically inactive. Now let me tell you CIP rule, and then we are going to find out chiral carbons. So everyone ready for CIP rule? Let's understand CIP rule. So everyone ready for CIP rule? Do let me know that everyone is ready for CIP rule. CIP rule. This is very, very important. The CIP rule is important for geometrical isomerism as well as optical isomerism. Very good. Now see, kids. C stands for one scientist name. This is also one scientist name, and this is also one scientist name. C stands for Kahan, scientist Kahan. C name. I for in gold. Oh my God, what's the name? In gold. And P for before log, pre-log. Fantastic name. Three scientists. These are three scientists, but no need to cram these names. Just remember CIP rule. So what is this CIP rule? This is not simple rule. This is gets really fantastic rule. Is everyone really interested in this CIP rule? See, CIP rule number one. CIP rule number one. So I'm going to deal with CIP rule number one. The element, the atom. Now question arises, atom should be present alone or the part of group. So this atom can be alone or the part of group. The atom alone or part of group. The atom alone. What is the spelling of alone? This is wrong. ALONE. Alone. The atom alone or part of group which is directly attached with the chiral carbon, which is directly attached with chiral carbon. So we have to focus on which atom. The atom which is directly attached to the chiral carbon, with maximum atomic number, will be senior most. So seniority we have to find out. Now one question arises. So we don't know atomic number, then how to do it? Let me tell you, no need to cram the atomic number. Let me tell you. See, you know very well one thing, that fluorine, bromine, iodine, astatine, leave astatine. As we move down the group, atomic number increases or decreases. Do let me know in the chat section. Atomic number increases or decreases. Do let me know, everyone. Be quick in the chat section, everyone. Atomic number increases or decreases? Definitely atomic number increases, right? And as we move from left to right, for example, if I say hydrogen, carbon, nitrogen, oxygen, fluorine, like that. So atomic number will increase or decrease. Let me write down in one line. If I write hydrogen, carbon, nitrogen, oxygen, fluorine, the atomic number will increase or decrease. Do let me know. Atomic number will increase. So atomic number will increase. Definitely atomic number is going to increase. So what I'm saying, no need to cram the atomic number. This is just giving an idea about it. What's the atomic number? Now see, if I say one carbon is over here and it is attached with one hydrogen, okay, one chlorine, okay, one bromine, okay, one iodine. So this carbon is being chiral or not? Answer is yes. So this carbon is declared to be chiral. This is chiral. Why chiral? Because all the four atoms are different. So this is chiral. This is very simple question. This is very easy. But if I say I have taken one more carbon, this is attached with CH2OH, CH3, CH2CH3 and CH2I. Now, what will you say? This carbon is chiral. Yes, this carbon is also chiral. But students will say, so how it is chiral? It should not be. It's not expected to be chiral. Why? See, you will say this is carbon, this is also carbon, this is also carbon, this is also carbon. All four are being carbon. But kids, if first atom is not able to decide the seniority, if first atom is not able to decide seniority, then see the second atom. Which second atom? The topmost atom. Then see the topmost second atom for seniority. Now see, it's carbon's topmost atom attached to oxygen. This is carbon's topmost hydrogen, and this carbon's topmost is carbon, and this carbon's topmost is iodine. So who is senior most? Because all the carbons, they are same. Cherry baby, hello. Please help me. What's your question? This is which class number of isomer? This is after geometrical isomerism. First structural isomerism, then geometrical, and after geometrical this is optical isomerism. Cherry baby. Now see, this is, we have to see here iodine. This iodine is different. This oxygen is being different. This hydrogen is being different, and this carbon is being different. So this carbon is also chiral carbon. And let me write down, this is CIP rule number 2. So let me tell you CIP rule number 2. What is CIP rule number 2, kids? CIP rule number 2. What's that? What's that? If first atom is not able to decide, if first atom is not able to decide seniority order, then see the second atom, see the second topmost atom for seniority. Kids, are you able to understand? If first atom is not able to decide, then see the second atom. I hope that everyone is able to understand. Now for this one, let me tell you, let me give you one example, and do let me know, everyone, is this chiral carbon attached with iodine, CH2 iodine, CH2, Br and Br. What do you think? Is this carbon chiral? Do let me know in the chat section. I'm waiting for your answer. Is this chiral carbon? The yellow one is chiral carbon. Rudra, hi HSP sir. It's Rudra from AIMS Rishikesh. Oh my God. Welcome Rudra Yadav. How you got this channel? Oh my God. Thanks Rudra Yadav. Rudra, it's really fantastic. I'm really feeling happy to see you over here. And that's why I'm telling each and everyone this is the best platform where we can meet, and this is not having any boundaries. Fantastic, Rudra, fantastic. Now do let me know everyone, is this compound having chiral carbon? Priyanka is saying no, this is not chiral carbon. Rest of other students, do let me know, is this carbon chiral? Hey everyone, where the energy level has gone? What are you doing? What's going on? What's wrong with you? The only one answer I have got, that is from Priyanka, and Priyanka is saying no, this is not chiral. Rest of other students, I want to see answer from you. No. So Sangeeta Govindasamy is also writing no. Kids, I can't wait more. And let me tell you, this carbon is exactly chiral carbon. Yes, this is chiral. Yes, this is chiral carbon. Chiral carbon, kids. This is chiral carbon. Now see how. Everyone see to it. Everyone see to it. This is the senior most. See, this is carbon. To carbon directly attached atom is iodine. Iodine. And this iodine is not directly attached. This iodine is not directly attached because this carbon is attached with carbon and then iodine. So we have to consider carbon and then iodine. This is chiral. This is carbon, this is also carbon. These two carbons are not same because the first atom is not able to decide. This carbon is saying, hey, I'm being carbon. This is also saying, hey, I'm being carbon. But your senior most is iodine and its senior most is bromine. So we have to consider these. Now this is simply bromine and this is not simply bromine. We have to consider along with bromine, the chiron is also there. So we will consider it to be CBr. This is CBr. This is just Br. This is just iodine and this is Ci. So this is Ci. This is CBr. This is just I. This is Br. Are they different or same? Hey kids, everyone, I will come to you. I will come to your house and I will just beat you if you're not able to understand. Definitely I will come over there. Definitely I will come over there. Just try to understand. Just try to focus. Hey kids, everyone do let me know that are you able to understand it? Everyone do let me know. Are you able to understand it? You got it or not? So this compound is chiral. On only one chiral carbon, only one chiral carbon, only one chiral carbon means only one chiral carbon, only one chiral carbon means what? Only one chiral carbon is indicating that this compound is optically active. This compound is optically active, optically active. Now kids, let me take well-known example from your biology only. Definitely, I will give you selection, kids. I'm not teaching here for views. I'm not teaching here for publicity. I am teaching for your rank. Just give me your time and my team and myself, HSP Baba, will give you rank, kids. There is nothing. Oh my God, Sangeeta is saying like that. Okay, now see. Well-known example, that is lactic acid. From your bio, I'm taking lactic acid. Lactic acid. You know very well lactic acid. So you should know the formula of lactic acid. If you don't know, then your teacher is going to give you 0 marks. CH3, CH, OH, COOH. This is your lactic acid, kids. Now, wow, K. Smitra, fantastic. I am really happy that you kids really studying. Otherwise, this is not easy job. This chapter is not that easy. It's tough. If you're sincerely with your perseverance, with hard work, you are really going through it, then only you are able to understand, and that is going to give you full marks. Now see kids, this is being lactic acid, and if I draw lactic acid, see this is the condensed formula. I would like to say this is being the condensed formula, condensed. This is being condensed formula. This is being your condensed formula. Now let me write down properly this lactic acid. Then we will get it like this: CH3 CH OH COOH. Now kids, do let me know, is this compound lactic acid is having chiral carbon? Yeah, Ramakant, definitely. Dasari Ramakantji, definitely, sure. Now do let me know, is this compound, if I focus over here, this carbon is chiral? Is this carbon chiral? Quick response I want in the chat section. Quick response. Yes, this is being chiral. Just see to it. This is carbon. This is also carbon. But this carbon is attached with hydrogen. So this is CH. We will count it CH. But this is oxygen. Then we will say CO. And this is just O. And this is H. Just see. Just focus over here. They are different. This is CH. This is just H, this is just O, and this is CO. All they are being different. So this compound is chiral. So lactic acid is optically active. Optically active. Optically active. You got it? Everyone got it? This is optically active compound. Now kids, let me tell you CIP rule number 3. The CIP rule number 3 is not easy. Let me tell you, let me explain. What is the name of this batch? Trisha, this is this is your Conquer batch. Conquer. NEET Unacademy Conquer batch. Conquer itself means yes, the success. Okay. Now see everyone. CIP rule number 3. CIP rule number 3. CIP rule number 3. Just focus. This is really tough rule. We have to focus over here because this is going to help you in your GI also. It holds a hell lot of weightage. Now see everyone. CIP rule number 3. In case of multiple bonds, in case of multiple bonds, we have to draw hypothetical structures. Hypothetical structures. Now kids, once if you see this hypothetical structure, you must be thinking in your brain that we can draw anything. We have got the freedom to draw anything. No kids, you haven't got freedom. So hypothetical structures for comparing seniority, Now kids, I will tell you how to draw hypothetical structures. Are you ready? Is everyone ready, kids? How to draw hypothetical structures, I will let you know. Are you ready? With full Josh? Now see, everyone see to it. If I give you one compound like this, our examiner is going to give you one compound like this, and he has written CHO and COOH. Oh, let me take another example, some tough example. CHNH2 NH2 and CN and iodine and hydrogen. He has given this compound. Now he is asking, this compound is having chiral carbon. Is this compound having chiral carbon? So it's very easy. Yes, it's this compound is having chiral carbon. See, if I give number 1, then definitely this is going to get number 1 and this is going to get number 4. Number 1, number 4. This is most senior. This is your senior most, right? And this is your junior most. Junior most. Right, kids? Now, out of CN and this one, which one is senior? That is really a great problem, a challenge. Now, let's compare these two compounds because their starting atom is carbon. This is carbon, this is also carbon. Both of them are being carbon. So, let's compare their seniority order. How to compare it? So, just for comparison, let me write it down this. I have drawn it like this. Then let me bifurcate, and first of all let me write down as they are given. This compound is given like this, CN. Can you write CN in the expanded form? Then I will write it like this, C triple bond N, CN. Is it okay? CN I will write like this. Now this C and N, in between C and N, there is one sigma and rest of 2 are pi. In between carbon and nitrogen, one is sigma and 2 are pi. Anyone can be treated as sigma and pi. Now how to write down the hypothetical structure? See everyone, how to draw hypothetical structure. Hypothetical structure. See, sigma bonds I will write down like this only. These are the sigma bonds I have written like this. Is it okay? Sigma bonds I have written as it is in the same form. Now carbons, how many pi bonds I have broken? 2 pi bonds I have broken. So the 2 pi bonds I have broken will be like this. 2 pi bonds. And nitrogens, 2 pi bond I have broken. They will be like this. Is this much okay? Is this much okay? Yes. Now, everyone do let me know, this carbon was bonded to which atom through pi bond? This carbon was bonded to nitrogen through pi bond. So, by my choice, I have to write down here nitrogen, here nitrogen. Why I have written nitrogen? Because I have broken its bond. I have broken its friendship with nitrogen. So nitrogen atom I have to write down over here, and this nitrogen was attached to carbon. I have to write down over here carbon. So this is the hypothetical structure. This is the hypothetical structure. Now I am supposed to compare this with this, and if I say this carbon was like this, H, NH2, NH2. Now if I am going to write, I will write C, H, N and N. Now these two carbons are same, so they are not able to decide who is senior because both the carbons are same. This carbon is saying I am attached with how many nitrogen? 1, 2, 3 nitrogens. This carbon is attached with 3 nitrogens. Can you see? This carbon is saying I am looking like that I am attached with 1 nitrogen. I am looking like attached with only 1 nitrogen. Only 1 nitrogen, right? And it's attached with 2 nitrogens, so it is looking senior. But if you draw its hypothetical structure, it is attached with 3 nitrogen atoms, and this is attached only with 2 nitrogen atoms. So who is going to be senior, kids? Who is going to be senior? Definitely out of these two, this is decided to be senior. This is senior. So 1, 2, this will get number 2, this will get number 2, and this will get number 3. Agreed or not? By simply saying this was attached with two nitrogens and it was looking to be attached only with one nitrogen, but when we have drawn its hypothetical structure, it is found to be carbon attached with three nitrogens, carbon attached with three nitrogens, with three nitrogen atoms. It's everyone is able to understand. If yes, show me the thumbs up. If you're not able to decide, if you're not able to understand it, show me the thumbs down. I will explain once again. And if you are able to understand it, please show me the thumbs up, kids. Because this is the only way by which I can understand that yes, each and everything is going to your brain. Kids, how much hard effort I'm putting, you can understand. I'm telling you the each and everything. You are not going to get these things anywhere. Whether you study offline, you pay 2 lakh rupees, 3 lakh rupees, you go to different city where the food is not good, hostels are not good, and the quality of teachers even not good. So you are getting the best quality over here, kids. Everyone, very good, very good. Okay, let me tell you once again, let me take one more example. Don't worry. Let me take another example. Let me take another example. See. Everyone see to it. Let me take another example. If I take this atom, CH2OH and CHO and hydrogen, and if I say this is bromine, so definitely I would like to say this is senior most, this is at the last, and out of these two, who is going to be senior? So let me draw it. First of all, because this is the single bond only, this is the single. Why I am comparing these two? Because this is carbon, so there is tie in between carbon. So this CHO, let me draw this CHO in a proper way. How should I write CHO? CHO, see, this CHO was looking like this. This CHO was looking like this. But if I write it properly, the CHO is like this, CH double bond O. But its hypothetical structure, once it is coming, that write down hypothetical structure. How should I write hypothetical structure? Kids, those who are able to understand, try to find it out how to write. I'm going to write, just you can say, you are thinking it, bhomik, Somi the bhomik. Good evening, good evening. Yeah, I would like to say not only 5 months. You can crack NEET exam in 3 months, only 3 months. But dedication is required, perseverance is required, regularity is required, patience is required. Now see, if I say I'm going to write down its hypothetical structure, this carbon is attached with 1 sigma, 1 pi bond. Can you see? And this is sigma. So sigma should be written as such. Sigma bond should be written as such. No problem with the sigma bond. Now see, from where I have broken pi bond. That pi bond was attached with carbon and oxygen, in between carbon and oxygen. So I have broken the pi bond. Now who is crying? Oh, who is crying? Carbon is crying. Oh, my pi bond has been broken by HSP Baba. Oxygen is also crying. Hey, my pi bond is broken by HSP Baba. So both of them are crying. Now I ask carbon, hey carbon, who has broken your bond? Carbon is saying, don't ask me who has broken. My pi bond was attached with. With whom this pi bond was attached? With whom pi bond was attached? Carbon is saying, my pi bond was attached with oxygen. Oxygen. Oh, take it. Now I asked oxygen, with whom your pi bond was attached? It was attached with carbon. Oh, you keep it. You keep it. Now kids, just see to it. This carbon is just attached with one oxygen, only one oxygen, only one oxygen. Now this carbon is thinking like it is attached with one oxygen. Once you have drawn the hypothetical structure, it was found to be attached with two oxygen atoms. So now once you are able to understand, no need to write, you can do it in the air. Once it's clear, what's fundamentals are clear, you can do it in here, that this carbon is attached with two oxygens. So number 1, number 4, number 2, number 3, number 4. Why I am telling you all these things? Not only for chiral carbon. Later on, I am going to tell you RS system. For RS system, these will play really very important role. These are going to play really very important role. Now, you got it. So this carbon is chiral. This is chiral carbon, and this compound is optically active. Chiral carbon and compound is optically active. Now, kids, just to find out whether the carbon is chiral or not, no need of CIP. Just see with the eye of HSP. Let me tell you, just see with the eye of HSP. If I write down this compound, see everyone, if I write down this compound, carbon, CH2, 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 I, carbon, CH2, 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 CH3. Now, in the examination, if this question has been asked, will you apply CIP rule? It's no need of CIP rule. See, this is different, this is different, these two are different. Now, this is being carbon, this is also carbon. This is carbon, this is also carbon. This is carbon, this is also being carbon. But this is iodine, so this is the winner. This is the winner. So it's winner. See, 1, 2, 3, 4. This carbon is chiral. Only one chiral. Only one chiral. Compound is optically active. Compound is optically active. Kids, so just see up to the last. Just try to see up to the last. If no difference is there, then the compound cannot be chiral. See, yeah, RS system, I will come. Somyadeep, I will come to that. Don't worry, I will come to that. Don't worry, I will come to that point. Now see, kids, if I write down one carbon like this, if I write carbon, CH2, 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 CH3, carbon, CH2, 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 CH3, Br, iodine. Just to let me know, is this carbon chiral? Is this carbon chiral, kids? Is this carbon chiral? No, it's not chiral. See, CH2, 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 CH3, CH2, 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 CH3, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 1 carbon, 2 carbon, 3 carbon, 4 carbon. They are exactly same. These two are exactly same. So these two are same. So this carbon is not chiral, not chiral. So which case it is? You can say this is like this CH2, Cl2, or CH2, Br2, or CX2, Y2. In the coordination chemistry, you will study C, A2, B2. All they are being same, and they can't be optically active, can never be optically active, can't be optically active. Everyone able to understand? Can't be optically active. Kids, everyone is able to understand or not? Now, so question will come, find out how many chiral carbons are there. But before that, let me tell you CIP rule number 4 and CIP rule number 5. Two more CIP rules are there. They are simple one. Let me tell you those. Yeah, optically inactive. So let me tell you CIP rule number 4 and CIP rule number 5. CIP rule number 4 and CIP rule number 5, because they are easy one, easy kill. So let me tell you. CIP rule number 4, in case of isotopes, The one with maximum mass is senior most, is senior most, is senior most. For example, if I say this is compound, this is attached with HD CH3 and CH3 14 isotope of carbon with mass 14. Is this carbon chiral? So kids, those who don't know this rule, they will say no. But just see, this is protium, this is deuterium. They are treated at different atoms according to CIP rule. So who is going to get number 1? Definitely this carbon is 14, nothing is written, so carbon 12. This is going to first number, this is going to second, this is going to get third, and this is going to get 4. So this carbon is chiral carbon. Everyone able to understand? So this carbon is going to be chiral carbon. Everyone is able to understand. Now CIP rule number 5. CIP rule number 5. Now CIP rule number 5 says, in case of bond pair and lone pair, bond pair is senior. Bond pair will be senior. Bond pair is senior. Bond pair is senior. Let me give you example of it. If I write C double bond C, C double bond C, if I write negative charge, lone pair, and here I can write C6H5, here CH3, and here let us write down bromine. So see, this is the case of GI. This is the case of GI. So who is out of these two? Definitely this is senior over here, and in these two, this is bond, and this is lone pair or negative charge, lone pair or negative charge. So this is junior and that is senior. This is being junior because lone pair or negative charge. Let me give you one more example. Don't worry, let me give you one more example. See, the well-known example of it is nitrogen, and this is the lone pair. You can see lone pair. This is hydrogen, this is C6H5, and this is being CH3. So see, who is going to get number 1? This is going to get number 1, number 2, number 3, and this is being lone pair number 4. So this nitrogen is chiral. In this case, carbon is not chiral, nitrogen is chiral. Nitrogen is chiral. So this compound is definitely having 4 different atoms. So this lone pair is also considered as one group. Mr. Panda, thank you. Thank you for understanding. Thank you. Thank you. Now see, it's all the rules I've told you. Now, just you are supposed to find out the number of chiral carbons in the following. Question is, find out number of chiral carbons First example is BrClHH. How many chiral carbons are there, kids? How many chiral carbons? So the answer is, this compound is having 1 chiral carbon. Why this is chiral carbon? And this is also chiral carbon, 2 chiral carbons. So reason is, this carbon is attached with bromine atom, hydrogen atom, This is CH2, but this is CHCl. Same here. So this is having two chiral carbons. Agreed or not? Two chiral carbons. So this compound is having two chiral carbons. Agreed, everyone? Is everyone agreed? Now see, if I write down this compound, CH3, CHCl, CHOH, C double bond O, OH. How many chiral carbons are there in this compound? How many chiral carbons are there in this compound? Kids, do let me know, everyone. So this compound is also having two chiral carbons. This can't be chiral because it is attached with three hydrogen atoms. This is chiral, and this is chiral. That cannot be chiral because it is attached with multiple bonds. A carbon attached with multiple bonds can never be chiral because these are same, right? Thank you, Killer Science. Thank you, everyone. So everyone is able to understand how many chiral carbons are there. The compound is having how many chiral carbons. So once the chiral carbons are same or different, doesn't matter. But if compound is not having any plane of symmetry, center of symmetry, then that compound is going to be optically active. Sir, clear nahi dikh raha. Poonam Rathi, everyone do let me know. Is the screen clearly visible to all of you? One girl is writing, Poonam Rathi, that sir clear nahi dikh raha. So everyone just do let me know. Can you see clearly? Yeah, that's really fantastic. Now see, kids, let me tell you the most important thing. I'm going towards most important thing. How to find out total number of optically active things or not. Why I have told you this thing, let me tell you. The experimental phenomena. See the experiment. What scientists did, they have done one experiment. Experimentally, how they perform the experiment. In earlier days, what was happening, when somebody was getting any compound, they were doing investigation on that compound with the help of one instrument. That instrument's name is spectrophotometer. Everyone say spectrophotometer. Everyone say along with me, spectrophotometer. Photometer. Its another name is polarimeter. So actually, just to find out whether the compound is optically active or optically inactive, there is one instrument. The name is spectrophotometer or polarimeter. This is the question of the examination. They will ask you how to measure whether the compound is optically active or inactive. This is the instrument. How this instrument works. See everyone, how this instrument is going to work. So we know that our light is sunlight or other lights. We can say they are what type of lights? Multi-directional lights. Kids. Light, that is sunlight or other lights, they are being multi-directional lights. And multi-directional lights is of no use. Multi-directional lights. Now, this light has to be passed through the prism. We have to pass this light through prism. Prism, you know, Nicole prism. When this light, multi-directional light, is going to pass through this Nicole prism, this light will become unidirectional. Kids, this light is going to become unidirectional. This light will become what? Unidirectional. So this light will become unidirectional. This is also known as plane polarized light. Unidirectional, you can say, or you can say plane polarized light. Plane polarized light. Plane polarized light, you can say. Now this light, plane polarized light, is allowed to move through the tube. This light is allowed to move through the tube. This light is allowed to move through this tube, and this tube is containing organic solution. This tube contains organic solution. The organic solution which we have to find out whether that organic solution is optically active or optically inactive. That organic solution is filled in this tube. Everyone getting my point? This organic solution is filled in this tube, which we are going to find out whether this compound is optically active or inactive. If this organic solution is optically active, this compound will rotate the plane polarized light. Let us suppose I am being plane polarized light, and I am being plane polarized light, and I am allowed to move through this organic solution. See, just like plane polarized light, and I am going like this. If this organic solution is found to be optically active, it will rotate the light. If it is rotating the plane polarized light in the clockwise direction, then everyone will say this organic solution is dextrorotatory. And if this organic solution is rotating the light in the anti-clockwise direction, everyone will say that this organic solution is levorotatory. Now see everyone, it all depends on the organic solution. If this light which was moving in this direction, it was going like this, plane polarized light. If the organic compound is rotating that light in which direction? If it is rotating this light in the clockwise direction, in this direction, clockwise direction, so everyone will say that this organic solution is dextrorotative because it has rotated the light in clockwise direction. So everyone will say this organic solution is what? Dextrorotatory. Dextrorotatory. It is taking too much time to write dextrorotatory. So they generally call it small d, or they can say plus sign. All means same. Either dextrorotatory, small d, or plus sign. Capital D, don't write capital D. Capital D is something else. We cannot write down capital D. Now, if this compound is rotating the light in anti-clockwise direction, then everyone will say that this compound, if it is rotating the light in anti-clockwise direction, then everyone will say that is levorotatory, or small l, or negative sign. Either of three things we can say. So just to tell whether the compound is optically active or optically inactive, for that we should need spectrophotometer, that is known as polarimeter. Without spectrophotometer or polarimeter, no one can say whether the compound is small d or small l. So small d and small l, no one can say by seeing the compound whether it is dextrorotatory or levorotatory, because it is an experimental concept, and small d and small l has nothing to do with capital D and capital L. Remember that, what I am telling you. First point I am going to tell you. What's the first point, kids? Small d and small l has nothing to do with capital D and capital L. What I am going to tell you, kids, do let me know. So small d and L, small d and L, small d and small l is an experimental concept. Experimental concept. No one can say whether the compound is small d and small l. Now, small d and small l has nothing to do with capital D and capital L. Capital D and capital L. Why? Because capital D and capital L are being relative configuration. Relative configuration, by simply seeing the compound, we can find out what is capital D and capital L. But small d and small l, they are being experimentally determined. Experimentally determined, or you can say these are theoretically determined. Theoretically determined. Kids, till now, are you able to understand? Wow, that's really awesome, Jyoti, Ajay Gaming. Now, kids, till now, is everyone comfortable? Because I'm telling you those things which you are not going to get anywhere. I don't know that, yes, very tough to get all these things. On the YT channel, you're not going to get all these things. So kids, do let me know. Are you enjoying it? Are you getting something from here? Now see, kids. So scientists, they have developed certain fundamental things to find out what type of configuration, what type of compounds they are having. So I will move towards these configurations, relative configurations, number of things. So everyone is ready for all these things. I was getting a lot of knowledge from you, HSP sir. Wow, that's really fantastic. Confidence. Now see, types of configurations. Types of configurations. So there are four types of configurations which we are going to deal for chiral carbon atoms. Four types, and these all four types are very, very important. See everyone, four types of configurations. Types of configurations. Types of configurations. For optically active compounds. See everyone. First one is R and S system. R and S configuration. This is the absolute configuration. Absolute. This is really very, very important. Absolute configuration. Second one is capital D and capital L configuration. This is being relative configuration. Relative. Third one is trio and erythrio configuration. Trio and erythrio. In 2016, question was based on this trio and erythrio configuration. And fourth one is small d and small l. This is experimentally determined. Now, number of questions are based on R and S configuration. As the sequence is indicated, the question's difficulty level will also be based on this, that R and S system is really very, very important. So let's try to understand what is R and S configuration. So is everyone ready for R and S configuration? So we are going to deal with R and S configuration. R and S configuration. R means rectus, S means sinister, but don't go for their spellings. R means rectus, not cactus, rectus, and S means sinister. It's not minister, it is sinister. Sinister. R you can say clockwise, and this is anti-clockwise. Let's understand RNS configuration. So we are going to deal with RNS configuration in two types of compounds. The compound number one is being Fisher projection formula, and second is being flying wedge and dash formula. Flying wedge and dash formula, wedge and dash formula, right? Fisher and wedge and dash formula. So first of all, we are going to deal with R and S configuration in, yes, Fisher projection formula. Everyone ready? Is everyone ready? R and S configuration in Fisher projection formula. Is everyone ready, kids? Do let me know. R and S in Fisher projection formula. Now see, so let me tell you some rules. I will write down rules later on. First, let me explain those rules, okay? First, let me explain those rules. Then only I am going to write down those rules. So, draw this plus sign. Draw this plus sign. Can you see this plus sign? And suppose if I have written iodine, bromine, let me write down iodine, bromine, chlorine. Let me take the easiest example first. This is the easiest, most easy kill question. And this is your chiral carbon at the center. At the center, this is being chiral carbon. This is Fisher projection. Now, this Fisher projection is having two types of lines. What these two types of lines are indicating, let me tell you first of all. This compound is actually like this, and these lines, this chlorine is like this. This chlorine is coming like this. See everyone, this chlorine should be like this. This chlorine should be like this. You must have seen sometimes the compounds are written like this, and you are afraid of what are these compounds. What are these compounds? See, sometimes the compounds are written like this. They are written like this. You must have seen sometimes. It's not a good figure. Let me draw it once again. Just wait. And bromine and iodine, it is chlorine, sorry, it's iodine, and bromine and hydrogen like this, bromine and hydrogen like this. Here bromine, sorry, here bromine. Have you seen compounds written like this? Have you seen the compounds like this? So this horizontal line says, what it's do, let me know. Horizontal line says whatever the atoms are written on horizontal line says coming towards observer side. This indicates coming towards observer side, This is foreign writer. In In foreign writer books, you will see, not in Indian writer. Indian writer books, they used to write like this. And who is going to make paper? Definitely Indian writer is going to make paper. So you will get like this, but you have to think like this. So horizontal line says coming towards observer, and vertical line says going away from observer, going away from observer, going away from observer. Are you getting my point, kids? Do let me know. First of all, let me show you. Don't worry, let me show you. Wait. If I show you these 4 atoms, let me show you 4 atoms. Just see to it. Everyone see to it. Can you see the 4 atoms? Everyone, can you see the 4 atoms? Yes. Now, try to understand. In this, one valency is coming towards your side. One is going away from you, right? This black one is going away from you. This green one is coming towards your side. And this blue and green, they are in the plane of board. If I put it in this board, this green is coming towards observer side. This blue and green, and this blue and this is also green. Let me change the pen. This is brown. Let us suppose, let me take, this was the compound. Oh. This is the compound. Let us suppose this is the compound. Now 4 different atoms and groups are there, kids. 4 different atoms and groups are there. Can you see? Everyone? Can you see? Now just see. This brown is coming towards observer side. This green is going away from observer. And these 2, black and blue, are in the plane of paper. Can you see? Now the same compound, if I show you like this, see. The same compound. This was the compound. If I show you like this, see, just see to it. Now 2 valencies, same compound, 2 valencies are coming towards observer side. Can you see? The same compound, 2 valencies are coming towards observer side and 2 are going away from observer. Let me draw it perfectly. This is 1V. Can you see the 1V? 109 degree. See, this green is coming towards observer side. Okay. This brown is going away from observer. Can you see? Now if I show you the same compound like this, now see, 2 valencies are coming, same compound, 2 valencies are coming towards observer side and 2 are going away from observer. But if I make this 3D into 2D in the copy, I will say this coming towards observer side is horizontal line, and the 2 valencies which were going away from you are being the vertical line. Now you can see the plus sign. The 3D figure, Indian writers, they are trying to show in 2D. Actually it was 3D figure, but they are trying to show like 2D. Everyone is able to understand? I hope yes. I hope that everyone is able to understand. Kids, do let me know that everyone is able to understand. Now the figure is given like this. You have to consider it like this. Now how to find out RS system? Just see. So the compound was given like this: iodine, bromine, chlorine, hydrogen. Rule number one says, whatever the atom directly attached to chiral carbon, assign number 1, 2, 3 according to CIP rule. So what should I say? According to CIP rule, this will get number 1, this will get number 2, this will get number 3, and this will get number 4, right? Just try to understand. Now the one who has got number 4, that is the least priority group. So this is going to be least priority group, kids. least LPG. LPG stands for least priority group. Everyone try to understand. So we are going to find out RS system. For RS system, what is the rule number one? Kids, do let me know what we have done. Rule number one, everyone do let me know. Rule number one. What is the rule number one? Rule number one, rule number one, rule number one, rule number one. Give number 1, 2, 3 on the basis of priority order. Give number 1, 2, 3, 4 on the basis of CIP rule. On the basis of what? On the basis of CIP rule. Now, rule number 2. Rule number 2 says, draw an arrow moving from 1 to 2. Moving from, it's very easy, just try to understand. Moving from 1 to 2. So I'm going to make an arrow moving from 1 to 2. Just see, I've drawn an arrow moving from 1 to 2. Can you see it is moving clockwise or anti-clockwise? Do let me know. So definitely right now it is going clockwise. It is going clockwise. Everyone, can you see it is moving clockwise? Now, rule number 3. Rule number 3. Rule number 3 says, if rule number 3, if LPG means least priority group is on vertical line, is on vertical line, if LPG is on vertical line, can you see this is being vertical line, then for clockwise arrow, this is R configuration, and anti-clockwise arrow, this is going to be S configuration. So do let me know this compound, in this compound, this LPG is on horizontal line or vertical line. Definitely this is on vertical line. So this compound's configuration is what? This compound's configuration is R or S. This is very simple. In my school time, teacher was rotating the copy and teacher was getting rotated by himself, and number of things were there, but it's very easy. R configuration. This is declared to be having R configuration. So this compound's configuration is R configuration. Now, rule number 4 says, it's easy. Rule number 4 says, if LPG is on horizontal line, then clockwise will be S and anti-clockwise will be R. If by chance, rule number 4, see, rule number 4 says, if least priority group is on horizontal line, then kids, what we will say, then clockwise arrow, for clockwise arrow we will say it is S configuration, and anti-clockwise arrow it will be R configuration. Now the problem is, once the time is getting passed, later on you won't be able to remember it, where was the LPG, what we have to decide. So again and again you have to revise. So we have not to do things like that we are going to revise again and again. We should need some parameters, some trick like that. No need of further revision. So let's see, let me give you one trick, HSP trick. See everyone, HSP Baba's trick, HSP Funda. HSP Baba's trick. What I said, LPG. I am talking about LPG. Everything is moving around LPG. If LPG was on vertical line, when LPG was on vertical line, LPG was on vertical line and arrow was moving, yes, arrow was moving clockwise. What we said, LPG on vertical line, arrow was moving clockwise. Completed what we said, it is R configuration. We said like this, and LPG was on vertical line and arrow was moving anti-clockwise. What we said, S configuration. We said like this. We said like this or not? Do let me know in the chat section. We were talking like this or not? When LPG was on vertical line, arrow was moving clockwise, we said it's RS. And if LPG is on horizontal line and arrow was moving clockwise, we said it is S configuration. And LPG was on horizontal line and arrow was moving anti-clockwise, we said R configuration, right? Is it right or wrong? Kids, do let me know. We were talking like this only or something wrong? When LPG was on vertical line, arrow was moving clockwise, we said R configuration, vertical line anti-clockwise, S configuration, horizontal line clockwise, S configuration. Now, so see, what's my name? My name is Harendra. H-A-R. This is my name. Harendra. H-A-R. You can remember H-A-R. Now, VCR. Very clear R. R means very clear R. R means you can write anything for R. Very clear R. R means make code for this, make trick for it. Everyone make your trick. Very clear R. R means anything you can say. Very clear R. R means very clear resonance, very clear right, very clear anything you can say. Very clear road. Very good. Nowadays road is not getting cleared. You see on the Himalayas, Kedarnath, Badrinath, roads are not clear. Very clear road. Wow, that's fantastic. Very clear road. You can say very clear road. Very clear road. Very awesome concept. Very awesome. Oh my god. Very clear road. So very awesome system. Very clear road. So very awesome. S. Very awesome. What? Very awesome subject. Wow. Very awesome subject. Very awesome subject. Very clear road. Very awesome subject. HCS. You can make anything HCS. Now you got it. Everyone got it. Are you able to understand? Now see, once you got it, let me know. Very awesome season. Very clear road. So very awesome season. Subject or season. Wow. That's fantastic. Very clear road. Very awesome subject or season. Now you can make your fundamentals, your tricks. Now you're perfect. You are perfect. Now see, I'm going to give you a question. Try to do it. Once if it is clear to all of you, one compound, first compound, let me say here is iodine, here is bromine, here is chlorine, here is CH3. So number one should be given to, definitely number one should be given to iodine, number two to bromine, number three to chlorine, and number four to CH3. And this is least priority group. Am I right? Everyone try to find out what is the configuration you are going to give. Now I have to draw an arrow moving from 1 to 2. This arrow is going clockwise or anti-clockwise? Anti-clockwise, dun 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 dun, anti-clockwise. So least priority group LPG is on vertical line, arrow is going anti-clockwise. Very awesome, very awesome, very awesome. What? Very awesome. S configuration, VAS, fantastic. Your answer is absolutely correct. So answer is S configuration. S is S, answer is S configuration. Everyone is able to understand? Is everyone able to understand this question? Now see, second question I am going to give. Just try to give me the answer for this question. So see, if I write OH, if I write CH2OH, if I write CH3, and if I write hydrogen, to whom should I give number one? To whom should I give number one? Kids, do let me know, to whom should I give number one? Over here, number one should be given to O. O, it's only O. This is C and this is C. It's O. Number two, number three, number four. So LPG, but first of all, I have to draw an arrow. 1 to 2, arrow is going clockwise. So LPG is on vertical line, arrow is going clockwise. We see very clear road, so it is having R configuration. Everyone, are you able to understand or not? Now I'm going to give you one tough question. See, everyone, see to it. I'm going to give you one tough question. If the question is like this, let me write down over here, Br, hydrogen, chlorine. Number one should be given to iodine, number two bromine, number three chlorine, number four this. Now kids, there is one problem. 1 to 2, we cannot go directly. Either we have to cross hydrogen or we have to cross chlorine. Kids, try to understand. Number one is over here, number two is over there. So if we are going from number one to number two, this arrow is going clockwise, and we are going from number one to number two, this arrow is going anti-clockwise. You can see there is problem. So this is going anti-clockwise. If we are going clockwise in the way, there is chlorine, and we are going anti-clockwise during the way. On the way there is being hydrogen. So which way is correct? That is the toughest question. From which side we should go? So remember that while moving from 1 to 2, we cannot cross highest priority group, the third highest priority group. We can cross LPG. If this type of situation is there, do remember, while moving from 1 to 2, 1 to 2, we can't cross third highest priority group. So we have to cross LPG, least priority group we can cross. So this is the right approach, that is wrong. That one is wrong, this is right. So what we are going to do, LPG is on vertical line, arrow is going anti-clockwise. Very awesome session. S configuration. Configuration is S. Everyone able to understand? Is everyone able to understand, kids? Is everyone? Now, if you are able to understand, I am going to teach you two things. Try to understand. Try to understand. First of all, I will give you a question and then I will explain it. Everyone, try to understand. The most important question for number of examinations is being asked like this. Find out the relation. Find out the relation in between, say, this is A and this is B. A is like this, B is like this. Everyone try your best to answer it. I, Br, Cl, hydrogen, and here is I, Br, Cl, hydrogen. So first option is enantiomers. Second option is diastereomers. Third option is homomers. Homomers also means identical. Fourth option is none of these. Then I will let you know each and everything about it related to it. But first of all, try to answer it. Let me check it out how much you know by your own knowledge. Yes. Priyanka is giving answer 1. Killer Science is also going for 1. Now kids, let's find out the answer of this question. This question is looking simple, but it may be simple or it may be tough. It depends which logic you have applied. Have you applied any logic or not? See, this compound is having just one chiral carbon and this is having one chiral carbon. So see, try to find out the RS configuration. If I say, let me give number 1, number 2, number 1, number 2, number 3, number 4, LPG, right? Now let me draw an arrow. Arrow is moving from 1 to 2 in clockwise direction and LPG is on vertical line. So vertical line, clockwise arrow, what should I write? VCR. This compound's configuration is declared to be R configuration. Agreed or not? Everyone agreed or not? Write down in the chat section R configuration. Somebody is writing diastereomer. Somebody is writing diastereomer. See, now same thing I am going to do over here. 1, 2, and this is 3 and this is 4. This is LPG. Now arrow is moving anti-clockwise, but LPG is on horizontal line. So LPG is on horizontal line and arrow is moving anti-clockwise. What should I write? R configuration. So this was R configuration. That is also R configuration. Am I right or not? This is attached. LPG is attached on horizontal line. LPG is on horizontal line and arrow is going anti-clockwise. R configuration. So its configuration is also R configuration. Am I right or not? Configuration wise, am I right or not, kids? Do let me know, everyone. Do let me know the configurations, whatever the configurations I have written, are they correct or incorrect? They are correct. So This is our configuration. Are you able to understand anything? This is R, this is R. I don't know whether they are dextro, whether they are levo, but they are same. They are identical. They are identical. So answer is neither enantiomer nor diastereomer. They are declared to be homomers and they are identical. Everyone got failed or not? Is everyone got failed or not, kids? Do let me know. Everyone got failed or not? Is everyone got failed or not? So those who got the wrong answer, show me the thumbs down. If your answer is right, thumbs up. So now see, let me give you one trick. Let me give you one fundamental trick. Not the trick, better to say fundamental trick. Fundamental trick. If if any compound is having only one chiral carbon, only one chiral carbon, only one chiral carbon. If any compound is having only one chiral carbon, then first isomer, second isomer relation. If the first isomer's configuration is R and second is also R, or the first is S and second is also S, if the first is R, second is S, or the first is S, second is R, what I am going to write, kids, try to understand. Everyone try to understand what I am going to write. Just apply your brain. What should I write? You just think by yourself what I am going to write. What I am going to write. R and R are identical. So definitely I will write R and R being identical. So identical. And identical are also known as homomers. Homomers. Not homologous. Homomers. SS being identical. RS being enantiomers. Enantiomers. And S2R is also being enantiomer. Now kids, you must start thinking where the diastereomer has gone. Remember that, mark my words, if any compound is having only one chiral carbon, then diastereomer will never exist. They will never show the relation of diastereomerism. Remember my point, remember my words. If just see to it, everyone, R identical, S identical, R to S enantiomer, S to R is enantiomer. If any compound is having just one chiral carbon, mark my words, everyone, what I am saying. If a compound is having only one chiral carbon, only one chiral carbon, then it will never have diastereomer with respect to chiral carbon. Now you must be thinking, sir, why? Why? So for that, we should know the definition of diastereomer. Let me explain it. First of all, Let me tell you the definition of Dice tumor. What are Dice tumors? What are Dice tumors? How will you define Dice tumor? Is there anyone who is going to tell me what is the definition of Dice tumor? So Dice tumors are those stereoisomers. Distereomers are those stereoisomers which are not mirror images of each other, which are not mirror images of each other. Or we can define Dice tumors in another way. See, in what way we can define Dice tumors? We can also say those stereoisomers which are not enantiomers. Those stereoisomers which are not enantiomers, which are not what? Which are not enantiomers, are diastomers, are diastomers. Now kids, let me define in a simple way. Let's keep it very simple. See to it. Everyone see to it. If I say C, fluorine, chlorine, bromine, iodine is Mr. X, is Mr. X. This is one man. This man's name is being Mr. X. This is the name CFCLBRI, Mr. X name. Now this Mr. X is having 1000, you can say 1000 Alia, daughter's name is 1000 Alia. It's just artificial 1000 Alia and 1000 Talia. Both are the daughters of Mr. X. Now, could you please let me know what is the relation in between Alia and Talia? These two are the daughters. These two are the daughters of Mr. X. What is the relation in between Alia and Talia? Do let me know. What is the relationship in between Alia and Talia? Everyone in the chat section. Definitely they are being sisters. They are being sisters. So if any compound is having only one chiral carbon, this is having just one chiral carbon, I will let you know that it can have just two isomers. One is R and one is S. This is R, then this is S. If that is S, this should be R. So they are sisters. Now, let me tell you one thing. One day what Mr. X has done, Mr. X switched off the lights. Mr. X switched off the lights. And said, Alia and Talia, 1000 Alia and 1000 Talia, randomly just hold your hands. Alia and Talia, without, no light was there. 1000 Alia and 1000 Talia just randomly, dum dum, by having one cloth over the eyes, and he said just hold hands, Alia and Talia. Now, once the light is there, once the light is switched on, then this Alia, maybe possibility that Alia is holding the hand of Alia. Alia is holding the hand of Alia. It is possible. It is also possible that Talia is holding the hand of Talia. Talia is holding the hand of Talia. And another possibility is that Alia could be holding the hand of Alia could be holding the hand of what? Talia. Alia and Talia, right? These are the only possibilities. Kids, do let me know. Is there any other possibility? No other possibility is there. Once Alia is holding the hand of Alia, once the light is switched on, they will say, oh, we are identical. What relationship we are having? We are identical or we are homomers. Homomers. Once the light is switched on, Alia and Talia, what I said, Alia and Talia is like RS. If this is R, Alia, this is R, this is also R. Identical. If this is S, this is S. Identical. And if this is R, this is S, what they will say? Oh, we are enantiomers. We are enantiomer. Now, let me tell you what is the definition of enantiomers. Now, one thing is clear to all of you that if only two types of things are there, then only one relationship can exist, not more than one relationship. Either they will be identical, identical is not the relationship, or the relationship is there, then only one type of relationship, no second type of relationship. Yes, if Alia is there, Talia is there, brother Changu is there, then definitely Alia, identical, Talia, identical, Talia, sister, Alia Changu, brother. Two types of relations. So, for two types of relations, at least two chiral carbons should be present. So, for a compound to be diastereomerism, so compound to show diastereomerism, at least two chiral carbons should be there. Kids, are you able to understand what I am talking about? Now, let me tell you what are enantiomers. Let me explain enantiomers. Kids, it's not easy, and it's not easy to teach also. It's not easy to teach also this subject, this optical isomerism. Alia and Thalia, yes. Now see, let me tell you about enantiomers. What are enantiomers? See kids, let me tell you about enantiomers. Let me take example of lactic acid. Lactic acid is well-known acid. Lactic acid. So lactic acid, CH3, CH, OH, and let me draw because we know RS system, so we know very well. So let me draw. This is lactic acid, CH, OH, COOH, CH3. So this is lactic acid, and if you see this lactic acid in mirror, let me place mirror. Let me place one mirror. This is mirror, and if you see this lactic acid in mirror, how it will look like? It's this lactic acid will look like this. OH, CH3, COOH, and H. So these two are mirror images. Once if I am going to explain these mirror images, first let me ask the thing which you are having with yourself, because this is the chemical compound. You are having your right hand. You see in right hand there is no plane of symmetry. If you divide this hand from any side, you won't be able to divide in two equal parts. So if you see this right hand in the mirror, you will see your left hand. Just try to see if you are having mirror. Just go smoothly, not in hurry. Otherwise, legs should get broken up. Take care of legs. Go slowly. See your right hand in the mirror. You will get left hand. Just see. Go and watch. Sunny Duhan, welcome. You see, if you try to see right hand in the mirror, you will get left hand. You see, let me show you mirror over here only. See, You will see it like this. Just see to it. This is going to see in the mirror. It will look like this. Just see. This is the mirror. Just say this is the mirror. In between this is the mirror. If this hand is going to see in the mirror, it will see like this. I'm good. Sunny Duhan, I'm good. Got it? Now just to let me know, this right hand and left hand are identical or different. Everyone do let me know. You must be having your right hand. You must be having your left hand. Everyone do let me know, is your right hand and left hand being identical or they are being different? Priyanka is saying different. Killer Science is saying identical. Kids, just see your right hand and just see your left hand. So Shiv Kumar is saying obviously it's identical. Kids, Ashwat, welcome, welcome. Now, everyone, everyone, you have to understand. Okay, now during winters, if you are having gloves, during winters, if you are having gloves, the gloves having fingers, is it possible to wear that right hand gloves in the left hand or left hand gloves in the right hand? Is it possible? NEET 2024. Kids, do let me know if you are having right hand gloves, finger one gloves, comfortably. Is it possible that with that is you can take, you can put on those right-handed gloves in the left hand? No, that means right hand is right hand and left hand is left hand. When we don't know about our hands, how we can understand the science? In the starting, 99% majority of these students, they said right hand and left hand being identical. No, kids, by chance, in someone's, if someone's hand is taken by God and God is saying in place of right hand, let me give you 5 left hands. By chance, if after 200 years, just say, if after 200 years, if God is saying, oh HSP Baba, give me your right hand and I will give you 5 left hands. So is it possible to place this left hand in place of right hand? See, if surgery is being done and if doctor is going to put this left hand in place of right hand, he will bring like this, and if he's going to bring like this, he will attach to this radio ulna, and he is going to put it like this. And see, the right hand was having thumb on this side, left hand will be having thumb on this side, and if he's going to join it like this, then you see the right hand was having smooth surface, the left hand thumb will come to this side but the rough surface. So right is right, left is left. Right hand and left hand, they are mirror images of each other. They are looking like identical, but they are not identical at all. They are two different hands. Right hand is right hand, left hand is left hand. They are looking identical, but not at all, not at all they are being identical. So this much knowledge you should have to have. If you want to get command on chemistry, visualization is necessary. Whatever the subject you were studying, you are going to study, this much of command you should have to have, and you should have to go for it. Kids, so this is the enantiomeric image of this. They are non-superimposable. Now see what is non-superimposable. Once the compound is not having plane of symmetry or center of symmetry, if you put this compound over this, the mirror image, if you put this compound on the mirror image, now see, superimpose means completely it is going to cover. No, see, the thumb is there, thumb is there. You rotate this hand, you rotate this hand, you see, rotate, you won't be able to cover it up clearly. So don't put like this, that's not allowed. In the plane of surface, you can rotate by 360 degree and it won't be able to cover it up. So this is known as non-superimposable mirror image. Now see, kids, this compound If I rotate 1, 2, the light is going in which direction? This is R or S. This is being LPG, LPG, and the arrow is going in the anti-clockwise direction, and LPG is over here. So this is having S configuration, and you see the mirror image will definitely have R configuration. Let me write down R. I'm not going to find out the answer. Automatically it is going to R there. See, number 1, number 2, number 3, number 4. Exactly, it is moving clockwise and LPG is over here. So this is R configuration. So these are non-superimposable mirror images of each other. So they are enantiomeric pairs. Enantiomeric pairs. That is non-superimposable mirror images. Non-superimposable, not impossible, impossible mirror images of each other. Mirror images of each other. Mirror images of each other. Kids. So these are enantiomers. Everyone is able to understand, kids. You liked it. So today, always remember that right hand is saying to left hand, A, you are my enantiomer. Left hand is saying to right hand, A, you are my enantiomer. We are not identical. We are an enantiomeric pair. Everyone, you can say they are looking like identical, but they are never identical. They are enantiomeric pairs. Meso compound, I will let you know. Princial, I will let you know what are meso compounds. Let me tell you, but this thing you are able to understand. Everyone is able to understand, not see. Thing is, racemization. Once we are able to understand enantiomers, let's understand racemization also. One by one, we will move one by one. How's the Josh? First of all, let me know how's the Josh. Have you got bored? Because it's almost 3 hours. It is going just 20 minutes left for 3 hours. Have you got bored or you are enjoying it? Everyone, just do let me know Vera level. Wow, thank you. Everyone is enjoying it or you got bored? Because the level of this optical isomerism is super, super awesome. Now everyone, if you're liking it, call your good friends. See, HSP Baba, the awesome teacher, is teaching you. Nowhere you are going to get this much of quality. Kids, tell your friends. You don't think like that. If I'm going to tell my friend that he is also going to get that much of knowledge, then the competition level will increase. No, kids. If your friend is preparing along with you, you have to prepare more hard, because always he will let you know that yes, I'm there. So if both of you are going to get more than 700 marks, so you are ahead of rest of others. So whether your friend, whether your enemy, if he is really hardworking or she is really hardworking, everyone, tell your friends. Wow, trick, very clear road, very awesome chemistry. Wow, wow, subject by Harendra chemistry, sir, highly active, rank me. Oh my god, trick, just wait. Killer science, what he's writing, wait. Very clear, let me write down. Very clear road, very awesome chemistry subject, very awesome subject chemistry by Harendra chemistry sir, by Harendra chemistry sir. Highly active rank maker. Oh my god, highly active rank maker. See everyone, take the what pick of this. Wow, wait. Let me see. Let me write down what Killer Science has written. Very clear route, very clear route, then very clear route, very awesome subject, very awesome subject. Then Harendra, highly active rank maker, highly active rank maker, Harendra sir, highly active rank maker. One is left. HCS, what's that? See, very clear route, very awesome subject. Harendra sir, highly active rank maker. Wow, claps. Killer science claps. Really. Now only one is left. One is left. HCS. What is that? Let me write on board. That's really awesome trick by Killer Science. Very clear route. Very clear route. Very clear route. Very awesome subject. Very awesome subject. Highly active rank maker Haren sir. Highly active rank maker Haren sir. Now only one is left. HCS. What's that? HCS. Everyone try. Harendra chemistry sir. Yes. Only one is left. HCS. This is for R and S configuration. R and S configuration. That's really awesome. This is mind blowing. No one is having this trick. Nowhere in the whole world, no one is having this type of trick. Now only one is left. Only one is left. HCS. What's that? HCS. Everyone, Harendra chemistry sir. Yes, Harendra chemistry sir. Oh, even I forget. I have forgotten this. Harendra chemistry sir. Harendra chemistry sir. Now let me take pick of it. Even I am not having this trick. The whole trick even I am not having. Let me take the one pick of this. I have forgotten it. Little bit I made in one class. That's really awesome. Fantastic. Kids, even I have taken the pick. You can take, yes, the screenshot. That's really awesome. Wow. Claps from my side. Claps to Killer Science. Fantastic. The whole class efforts are there and maximum from the Killer Science. That's really fantastic. Now see. Really awesome. I appreciate your hard work. This type of hard work is definitely going to give you the best rank in your examination. Now see, everyone. Resumization. Now, let us suppose if I am taking 60% dextrolactic acid and 40% levolactic acid. Now what do you think? It is just like if I take 60 milliequivalents of acid and 40 milliequivalents of base. What do you think? Just the neutralization process will take place? 60 milliequivalents of acid and 40 milliequivalents of base. Definitely. Wow, thank you, Killer Science. That's fantastic. So definitely here the dextro will neutralize the levo and cancellation of optical rotation will take place. Cancellation of optical rotation. This cancellation of optical rotation is known as resumization. What do you think? That complete cancellation will take place? No. Partial cancellation. Partial cancellation of optical rotation. Partial cancellation of optical rotation will take place. This cancellation of optical rotation, because dextro Suppose if light is moving like dextro and other compound is moving it like in the levo direction, so partial cancellation will take place. This partial cancellation is known as partial racemization. This partial cancellation is known as gets partial racemization. This is only known as, that is, partial racemization. Partial racemization. Now this racemization, partial cancellation of rotation, is in the same compound or two different molecules are there? Definitely two different molecules are there, because dextro is different molecule, levo is different molecule. So the reason is due to external compensation. External compensation. What is this external compensation, kids? External compensation means in between two molecules, in between two different molecules, or in between enantiomers. In between enantiomers. This is happening, taking place in between enantiomers. Now, if anyone is asking, this is case 1. If anyone is asking, now this mixture is optically active or optically inactive, do let me know, this mixture is optically active or optically inactive. So the answer is definitely this mixture is still optically active. Why this mixture is still optically active? Is there anyone who is going to let me know why this mixture is still optically active? This mixture is still optically active. Why this is still optically active, kids? Anyone? Is there anyone? Because enantiomeric axis, one enantiomer is in axis amount. So this is because of enantiomeric axis. Because of enantiomeric axis. Enantiomeric axis. Everyone is able to understand? So it is just like if I'm starving. Starving means I'm feeling hungry, and somebody has given me one truck pizza. Somebody has brought for me one truck, full truck of pizza. So if I'm going to eat, I'm going to eat the whole pizza? How much starving, how much hungry am I, doesn't matter, but the pizza will left over, because the pizza is in excess amount. Or suppose if I'm too much hungry and somebody is going to give me just one piece of pizza, so my hungerness will remain over there, because that pizza is in less amount, limiting region, that will not be able to neutralize my hungerness. Still I will be feeling starving. Everyone able to get it? It will show dextro rotation, because dextro is in axis. So the mixture will be dextro rotatory. So the mixture will be dextro rotatory. Mixture will be dextro rotatory. Kids, you got it? Dextro rotatory. Now case 2. See everyone, this is really awesome. Try to understand and you have to answer it. Case number 2. If I talk about case number 2, everyone see to it. If I take 50% dextrolactic acid and 50% levolactic acid, everyone do let me know, 50% dextro and 50% levolactic acid mixture. Let us suppose this green one is dextro, green one is being dextro, and this yellow one is levo. Do let me know what will happen. Dextro will completely neutralize the levo, and this time complete racemization will take place. Am I right or wrong? Complete racemization will take place. Complete racemization will take place, right? complete racemization, and the compound is optically inactive. As a whole, compound will be optically, or mixture will be optically inactive. Mixture will be optically inactive. Have you got it? Everyone got it, kids? Do let me know that everyone is able to understand. Do let me know, everyone. Everyone is able to understand. Yes, everyone is able to understand. Now, everyone must be waiting for meso one. Meso, isn't it? Everyone must be waiting for meso. But before telling you meso, let me tell you, if any compound is having how many chiral carbons, then how to find out total number of optically active isomers. How to find out total number of optically active isomers. Okay. Now see, kids, before I move ahead, do let me know that how much you are liking my teaching. Is it different, something different, or it is just bookish knowledge? Whatever I am teaching you, here the things are really required for visualization. Is this bookish knowledge or something out of the box? Now say, everyone. How to find out? Yeah, we can write calculation of total number of optically active isomers. See, everyone. Oh, Javeria Sayed. Everyone, put some cake. Top notch, sir. Awesome to the core. Sir, you are your session, sir. Thank you, Shiva Kumar. Now, everyone, put some cake or thumbs up sign, or write down happy birthday to Javeria Sayed. Everyone, because this day is really special, and you have to understand. Sir, till now, I never seen the sir teaching like listen like your very class. After 1 hour, definitely class will be bored. But I can say the HSP sir class never get bored. Oh, really? Thank you. Thank you. Thanks. Javeria Sayer, may Almighty God bless you with all happiness and prosperity, along with the best rank and successful life ahead. This is my prayer to Almighty God. Now, everyone, calculation of total number of optically active isomers when no form or representation, no representation of that compound have any element of symmetry. That is cos and cos. Now, its formula is total number of optically active isomers, total number of optically active isomers is equal to 2 raised to power whole n. 2 raised power whole n. Kids, 2 raised power whole n. What is this n? Could you please let me know? Could you please let me know what is this n? Definitely this n is going to be number of chiral carbons, where n is equal to number of chiral carbon atoms. Now see everyone see to it how to do it. So suppose if examiner is going to give you glucose, examiner has given you glucose, just find out total number of optically active isomers for glucose, kids. Now glucose, if we don't know glucose, just we know that C6H12O6, we cannot find out. For this we should know the structure of glucose. See everyone, the structure of glucose. Am I right or wrong? Do let me know. I'm trying to make it CH double bond O, CH2OH, 1 2 3 4, CHOH, 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 CHOH. Kids, do let me know. Have I drawn it properly or not? You are really intelligent, kids. Everyone do let me know. Everyone do let me know. Have I drawn this glucose properly or not? Properly. Now see, this is joined with multiple bond, can't be chiral. 1 chiral, 2 chiral, 3 chiral, 4 chiral. How many chiral carbons, kids? This glucose is having, this is open chain structure, or simply we can say glucose, this open chain structure is having n is equal to 4. Number of chiral carbons is equal to 4. So total number of optically active isomers will be 2 raised to power 4. That is 2 4s are 8. Should I write down 8 or 2 to 4 to 8 to 16? What should I write down? 2 4s are 8 or 2 into 2 into 2 into 2? That is being 16. What should I write down? 16. 2i is 16. Everyone is able to understand. Now kids, once they have given a particular question, categorically I am telling you what question they have given. See kids, they have given this question. Really this question, 50% of the coaching were not able to give the correct answer for this question. See kids, what question they have given. They have given question, find out total number of optically active isomers for alpha D glucose. Now kids, those who don't know what is alpha D glucose, how they are going to find out total number of optically active isomers? So what we are supposed to do, kids, try to understand. Alpha D glucose I am going to write. Just do let me know, am I right or wrong? I'm just trying my level best and you have to support me. If I'm wrong, do let me know, sir. You have drawn it wrongly. Absolutely, you have drawn it wrongly. Okay, kids. CH2OH. Now 1, 2, 1, 2, 3, 4, 5. H, OH, H, OH, H, OH, H, O. This is first carbon, first, second, third, fourth, fifth, sixth. Do let me know that I have drawn it properly or not. Is this alpha D glucose or not? Yes, this is alpha D glucose. Now, how many chiral carbons this is having? Do let me know. 1 chiral, 2 chiral, 3 chiral, 4 chiral, and this is one new chiral carbon. You can see this is new chiral carbon, and this is known as anomeric carbon. I will let you know why it is known as anomeric carbon, that I will tell you later on. But yes, this is also chiral carbon, anomeric carbon. Now kids, the hemiacetal, this is known as hemiacetal pyranose glucose structure, hemiacetal pyranose glucose structure, and this is having value of N. The value of N is equal to 5. So total number of optically active isomers will be equal to 2 raised to power 5, that is equal to 32, like our teats or peristomial teats in bryophyta, pteridophyta, wherever you must have studied. 32. Kids, Raju Ranjana, everyone do let me know, are you able to understand it or not? Everyone do let me know, everyone, are you able to understand it or not? Yes. So whether it is alpha D glucose or beta D glucose, whenever it is cyclic structure, whenever they are going to ask for cyclic structure, do remember cyclic structure will always be having 32. So when nothing is given, no problem. Now see kids, when simply glucose has been mentioned, when simply glucose is mentioned, then total number of optically active isomers will be 16. When alpha D glucose or beta D glucose or pyranose ring structure or furanose ring structure is mentioned, whatever the ring structure is mentioned, then all in these three cases the total number of optically active isomers will be 32. And for fructose, if fructose is given kids, fructose is given, then it should be 2 3s are 8. And if ring structure, furanose ring structure or any furanose ring structure is given, alpha D or beta D, doesn't matter, it can be alpha or beta, then it should be 16. Now you must be thinking, sir, for fructose, how to do it? How to do it for fructose? Now see kids, if you know the structure of fructose, this is fructose, CH2OH, CHOH, 3 carbons, 4 carbons, CHOH, 5 carbons, CHOH, 6 carbons, CH2OH. Now see everyone, this is not chiral, this is not chiral, this is chiral. Oh, this is not fructose. Here it should be C double bond O, right? It's C double bond O. Ketonic group is there. Keto fructose. Now, how many chiral carbons are there, kids? This is not chiral. This is not chiral. This is chiral. 1, 2, 3. Only 3 chiral carbons are there, kids. So N is equal to 3. So total number of optically active isomers will be 2 raised to power 3. That is being 8. Everyone got it? Now if I draw its ring structure, how I will draw? Just see to it. COH, CHOH, C, it's not COH, carbonyl group, So see, CH2OH, CH2OH, and this COH, 1 carbon, 2nd carbon, 3rd carbon, 4th carbon, 5th carbon, 6th carbon, 1, 2, 3, 4, 5, 6, CH2OH, and this carbon's oxygen is attached with this, and CHOH, CHOH, CH. Now you see, just see to it, This is first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, and this is anomeric carbon. This is one new chiral carbon, and this OH and this OH are on opposite side. So we'll say alpha, alpha D fructose, alpha D fructose. Now kids, you can see how many chiral carbons are there. One chiral carbon, two, three, four. So this is hemiketal furanose ring structure. You can see hemiketal furanose ring structure. Hemiketal furanose ring structure. Furanose ring structure. So here the n value is equal to 4. So 2 raised to 4, that is being 16. Everyone is able to understand? Kids, how is the energy level? Kids, how is the energy level? If your energy level is getting down, do let me know. I will take second part of optical isomerism. If your energy level is okay, then do let me know. Everyone, do let me know how is the energy level. Are you able to understand each and everything? If yes, then do let me know. Need break. Okay. Okay. Okay, everyone is asking for break. So let's do one thing. Right now it's 21:10, means 10 past 9. Right now it's 10 past 9. So, okay. So let's meet at 9:30. That will be better. 9:30. Should we meet at 9:30, everyone? 9:30. Everyone do let me know. 9:30 will be better. Okay. So let's meet at 9:30. But you have to come back, okay? You have to come back. Promise? It will take, let me tell you, I will take 2 sessions for this. This is the first half. Second half means after break I will let you know, but it is not going to get completed. One more lecture I will take. Okay, kids, or I will try to complete it within 1 or 1.5 hours. But if it is not getting completed, then it will require one more lecture. Then I will let you know. Okay. So everyone, you have to come with full on energy, not to come only. You are supposed to come with full energy, right? Everyone, you have to come with full energy. So it's a break. Energy break, right? Energy break. Welcome back once again, kids, to yours Unacademy NEET English channel. This is your Conquer Batch. Everyone, just see, am I on time or not? I'm better to say in time, right? Or you can say on time, doesn't matter. But yes, my all dear students, I think now you can study with more focus because you must have taken something, some source of energy. So, killer science is there, rest of other students are there. Yes, sir, you are on time. So, time is really very, very important. But yes, to study with full on energy, ultimate source of whatever the things, that is the energy ATPs, they are also required simultaneously. So it's better to have break after a short time. Yashir Mir, welcome. So without wasting even a single minute, let's start once again. Let's back. So kids, I was telling you about the racemization and I have told you that you must be waiting for meso compounds. Before I proceed towards meso compound, let me tell you very clearly the case number 1 and case number 2, because there's too much difference in between case number 1 and case number 2. So here is case number 1 with the white line and here is case number 2. So what's the difference between case number 1 and case number 2? Let's try to understand. Case number 1 and case number 2. Just see. In case number 1, as I have told you, in case number 1, as I have told you, what? Total number of optically active isomers is equal to 2 raised to power n. This case I have already explained. Then what's the need to tell you once again? Yes, this is the point. See, 2 raised to power n, where n can have even or odd. This n can be even or odd. The number of isomers will not get changed. The value of n can be even or odd, doesn't matter. But the condition was required for case number 1. The condition was no isomer, no representation should have plane of symmetry or center of symmetry. This was the condition required over there for the case number 1. Then only this case was valid. Now if I talk about case number 2, case number 2, kids, if any representation of compound, if any representation of compound is having plane of symmetry or center of symmetry, that total number of optically active isomers will not be equal to 2 raised to power n. They will be less than that. Then total number of optically active isomers value will be less than this. Then the formula will get changed. In this compound, case number 1, there was no meso. If I talk for this case, number of meso isomers was 0. No meso isomers were there. But this case number 2, the value of meso should not be 0. For this case, meso isomers will not be equal to 0. they will have some value. Means in case number 1 there is no mesoisomer, but in case number 2 mesoisomers exist, and I will let you know here. If n is even, then different formula. If n is odd, then different formula. So even and odd will have different formula. So two subcases will arise. Two subcases will arise. What are the two subcase? Subcase A and subcase B. Subcase A with even number of chiral carbons, that is the value of n is even number of chiral carbons, and subcase B odd number of chiral carbons, and they will have different formula. Now everyone ready? So Kit Yashir Mir is asking, this formula is valid only unsymmetrical compounds. Yeah, this formula is valid for unsymmetrical, means when none of the representation. Then how to find out whether the compound is belonging to case number 1 or case number 2? This question must be arising in your brain. Then how to find out whether the compound is belonging to case number 1 or case number 2? This can be your question. Now see, let me tell you. See, if I draw one compound like this, try to understand the difference. If I draw one compound like this, CH3, CHBr, CHCl, CH something OH, CH2, COOH. This is first compound. And if I draw second compound like COOH, CHBr, CHBr, CH3. Now let me draw third compound, COOH, CHBr, CHBr, COOH, because in the examination no one will be there to tell you that this example belongs to case number 1 or case number 2. No one will be there. You have to decide by yourself. Now see, try to understand. Whenever you are going to find out whether it belongs to case number 1 or case number 2, see from your extreme right hand side and extreme left hand side. On the extreme right hand side there is COH, and extreme left hand side there is CH3. Are they same or different? Are these two same or different? Let us say this is R1 and R2. Are R1, R2 same or different? They are different. So this will belong to case number 1. This belongs to case number 1, that no symmetry, never symmetry can exist. Symmetry cannot be present in this compound. Same, just see extreme right hand side and extreme left hand side. Are they same, different? They are being different. So this also belongs to case number 1. Now see, in the last compound, the right hand side is COH, the left hand side is being COH. Now start moving from right hand side towards center. You'll start moving, and from left hand side towards center you start moving. You see the symmetry is appearing. That means this belongs to case number 2. This is case number 2. Everyone, are you able to see? Can you see how to find out whether the compound is under the category of case number 1 or under the category of case number 2? Is everyone able to understand? Do let me know in the chat section. Are you able to understand whether it is going to belong to case number 1 or case number 2? Yeah, Yashir Mir, I will definitely. Now everyone is able to understand. Now see, so let's deal with case number 2. So I am going to deal with case number 2. Everyone see to it. case number 2. Now case number 2, subcase A. Subcase A. So total number of optical isomers is equal to total number of optically active isomers plus mesoisomers. Now just see what is the formula for this. 2 raised to power n minus 1. See, total number of optically active isomers in the earlier case it was 2 raised to power n, but here 2 raised to power n minus 1 power minus 1 plus 2 raised to power p minus 1. Now what is this p? Where p is equal to n by 2. What is the value of p? P is equal to n by 2. This is the formula. Now let's apply the formula. By applying formula, we will try to find out the answer, and manually also we are going to do it. Means with the help of visualization. Both the methods I am going to apply without formula, with formula. First, let's find out one compound with formula. So everyone is agreed. Now see, just try to find out. Let me take example of tartaric acid. Now the question arises how to write down tartaric acid. Just try to find out. CH3 CHOH. So that was lactic acid. This was lactic acid. You can understand this was lactic acid. Can you understand lactic acid? Now from the lactic acid, remove this CH3. Now same thing repeat on the left hand side. Same thing gets repeated. CHOH, COOH. This is the way how to write down tartaric acid. Examiner can ask what is the formula of tartaric acid. Once this question has been asked in your previous examination, what is the formula of tartaric acid, how to write down tartaric acid. This is tartaric acid. So let me write down tartaric acid properly. COOH, COOH. Now in the examination, no one will be there to let you know whether this belongs to case number 1 or case number 2. What I have told you, just see your extreme right hand side and just see your extreme left hand side. Yes, Shimrit. Now let me know if you see your extreme right hand side, and once if you see your extreme left hand side, do let me know that if you move from that side toward this side, both the side, you will get some symmetry over there, this side, and toward this side you will get some symmetry. Can you see? That means it exactly says it belongs to case 2. It belongs to case 2, everyone. Now see, so how many chiral carbons are there? If I say chiral carbon, this is one chiral carbon and this is being second chiral carbon. 2 chiral carbons are there. So n value is equal to 2. Everyone got it? The value of n is equal to 2. Now just apply total number of isomers. Total number of isomers is equal to total number of optically active isomers. Total number of optical isomers is equal to total number of optically active isomers plus mesoisomers. And what was the formula, kids? Formula was 2 raised to power n minus 1 plus 2 raised to power p minus 1, and the value of p was n by 2 minus 1. So if I apply the formula, what I am going to get? 2 raised to power 3 minus 1 plus 2 raised to power, not 3, the value of n was 2 only, you know. The value of n was 2. 2 raised to power 2 minus 1 plus 2 raised to power 2 by 2 minus 1. How much it is going to come? 2 raised to power 1 plus 2 raised to power 0. So 2 raised to power 1 will 2 and any power 0 is 1. So the answer is coming out to be 3. You can see very clearly, everyone. Now total number of optically active isomers, if anyone is asking, total number of optically active isomers 2 and total number of meso, that is 1. Number of meso is being 1. Now formula just increases the speed. Formula is not going to tell anything. It's not going to visualize, it's not going to give you knowledge about it. It's just telling you speedily the correct answer. So if you don't know, if you don't have knowledge, you won't be able to apply the correct formula. So we should have in-depth knowledge. So how many of you ready to get in-depth knowledge of this? Now, this is your tartaric acid and we are not able to understand anything about tartaric acid. Tartaric acid. Now let's see the visualization. This is the formula based. This answer we have got just formula based answer we have obtained. Speedily we got the answer which we are not able to understand too much. Yes, Priyanka, very good. Now see, the same thing we are going to visualize. Now visualization part, just see to everyone, see to it, visualization part. If I draw the compound, I will draw it like this. This is being tartaric acid. Just see to it, everyone. This is being tartaric acid. COOH, CHOH, CHOH, and COOH. How many chiral carbons are there? Definitely one chiral and second chiral. Two chiral carbons are there. Everyone see to it. No plane of symmetry is there. Two chiral carbons are there and no plane of symmetry there. So plane of symmetry is not present. So this compound will be optically active. That's why this compound is optically active. This form of compound is optically active. Just see, if this is being optically active, I will let you know one more thing. If this compound is optically active, both the chiral carbons configuration will be same. Either they will be RR or they will be SS, but both the chiral carbons configuration definitely is going to be same. Just see to it. If I say this carbon, so number 1 CIP rule, number 2 CIP rule, number 4 this is being LPG, least priority group, and this is going to be third. Now if I move an arrow 1 to 2, how it is moving, clockwise or anti-clockwise? Definitely it is going anti-clockwise. So killer science, you made one trick. Now help me. So 1 to 2, LPG is on horizontal line, anti-clockwise arrow R. So this is said to be R configuration. Agreed? Everyone agreed? R configuration. So definitely this will also come out to be R only. See, it will also come out to be R. 1, 2, and arrow is moving. Just see, anti-clockwise, and least priority group is on horizontal line, right? Now HAR, Harendra sir, so this is also being R configuration. So RR configuration. Now one fantastic thing I'm going to tell you, if I put one mirror over here, so we will get the mirror image of it. We are going to get mirror image of it. So I placed mirror, this is mirror, let us suppose mirror. Now in the mirror we are going to see, we will get mirror image of it. See to it, everyone. What's the mirror image we are going to get? We will get something like this. It's mirror image. OH, H, H, OH, COOH, COOH. So this is the mirror image of this compound, and we know that when the compound is optically active, means not having plane of symmetry, then its mirror image will be the enantiomer. And already I've told you, for opposite of R, it should be S, opposite of R, it should be S. That means it is supposed to be having SS configuration, but let me not write down, just try to find out. If it is not SS, then I'm a bad teacher, I'm not a good teacher. And if it is SS, then definitely whatever I taught you, that's going to be get proved, definitely. Now see everyone, so if I write, here is 1, here is 2, arrow is going clockwise, and LPG is on horizontal line. LPG is on horizontal line, arrow is going clockwise. HC, what should I write? HC, HC, S. So this is being S configuration, right? Now here in this, if you see, if I say 1, 2, arrow is going clockwise, arrow is going clockwise, and LPG is on horizontal line. So horizontal line, arrow is going clockwise, S configuration. So opposite of R, S, R, S. So these two are being optically active, and they are enantiomeric pairs. They are enantiomeric pairs. So 1 and 2, these two are enantiomeric pair. I will say these two are being enantiomeric pairs, and they are optically active. Enantiomeric pairs. And enantiomers are always optically active, so these are optically active. Optically active. Can you see? Optically active, kids. Now, if I draw the third one, see the third one. If I draw third compound, just see to it, everyone. COOH, CHOH, OH, HCOOH. Now see, this is also having two chiral carbons. What you can see, this was not having plane of symmetry, this was not having plane of symmetry, but this compound, what do you think, is having plane of symmetry or it is not having plane of symmetry? Kids, do let me know, is this compound having plane of symmetry or not having plane of symmetry? Do let me know. So you can see this compound is having plane of symmetry. Plane of symmetry is present. Once the plane of symmetry is present, even though it is having two chiral carbons, but because of plane of symmetry, this compound can't be optically active. Everyone, it is having plane of symmetry, so this compound is going to be optically inactive. Optically inactive. Everyone is able to understand? Now, let me tell you some more thing. When any compound is having chiral carbons and then also plane of symmetry is present, such type of compound is known as meso. What is meso compound? If plane of symmetry or center of symmetry is present along with chiral carbons, then the compound is known as meso. So let me write down this as being meso compound. And let me tell you one special thing about meso. It's one chiral carbon must be R. Another chiral carbon must be S configuration. I don't know which one is being R configuration and which one is having S configuration, but definitely if one chiral carbon is having S configuration, then another chiral carbon must be having R configuration. And let's try to find out. Everyone, are you ready? Just see, if I say 1, 2 and LPG, and arrow is moving clockwise. So I will say LPG is on horizontal line clockwise, HCS, this is S configuration, 100% this will come out to be R. I'm not going to write. You just try to find out the lower carbon will definitely come out to be R configuration. Let me show you. This is 1, this is 2, CIP rule, and arrow is going anti-clockwise. And LPG is on horizontal line. Killer signs, you have told me the trick, everyone. So horizontal line, anti-clockwise, Harendra sir. So this is our configuration. Now kids, on the first page, we have gone through formula wise, but formula just increases the speed. Formula never let us know anything what is going to happen. It's not going to teach us, it's not going to visualize about the particular thing. So this is everyone. Now let me tell you special thing about this. So these are the 3 optical isomer. One question must be coming to your mind that sir, this is optically inactive, but then also how it is optical isomer. Number of questions must be coming in your brain, but let me tell you, these are 3 optical isomers. Out of these 3 optical isomers, 2 are being optically active and 1 is optically inactive. So please little bit slow, just let us know, otherwise we will get confused. Now see everyone, see, if I draw this compound, over here, just try to understand. There was not too much space. Let me tell you over here about this compound. COOH, 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 COH, OH, H, H. So we have seen that the light 1, 2, it was going like this. In which arrow? This arrow was going anti-clockwise, and this arrow is coming, you can see, clockwise. You can see very well clockwise. That means this is going over here. LPG is at this place. So what I should say, that anti-clockwise LPG, horizontal anti-clockwise, this is R configuration and this is being S configuration. So half portion is rotating the plane polarized light in the clockwise direction and half is rotating anti-clockwise. Half portion of compound is rotating the light, half portion is rotating plane polarized light in clockwise direction and other half is rotating in anti-clockwise. Am I right? Another half or other half is rotating light anti-clockwise. Now kids, if I'm plane polarized light and I'm moving like this, ding 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 ding, half of the portion rotated light in the clockwise direction and another half rotated the light, plane polarized light, in the anti-clockwise direction. So when I come out from the solution, I entered like this plane polarized light. Once I am going into the solution, half molecule has rotating in clockwise direction, another half once again rotated like this. Once I am coming out, what others will say, oh, nothing has happened to the light. But light will say, oh, you don't know, I have been rotated just inside the molecule. Half portion has rotated in the clockwise and another half in the anti-clockwise. And you, spectator eyes, spectator public, you are saying nothing has happened. You can't see. Have gone mad. So light is talking like this, kids. So this is within the compound. This, all these things are happening just inside the compound. Am I right? This rotation cancellation is within the compound. This is happening within the compound. Cancellation of rotation is within the compound, within, and within compound means intramolecular. So this is known as internal compensation. That Racemization was example of external compensation, but meso is optically inactive due to, yes, internal compensation. That was external compensation. Here it is internal compensation, kids. Internal compensation. Everyone able to understand internal compensation? So why meso compound is optically inactive? So the reason of meso compound or meso tartaric acid to be optically inactive, the reason is due to what? Kids, let me know. Due to internal compensation. You got it? Everyone got it? Now, question arises when it is not optically active. Once mesotartaric acid is not optically active, then why it is known as optical isomer? So kids, if I say optical isomer, when I talk about optical isomer, when I am going to talk about optical isomer, see kids, optical isomer means they have rotated the plane polarized light. Rotated plane polarized light. That's all. That's it. Nothing more than that. Now, if due to their rotation cancellation took place, then we will say optically inactive. If cancellation is not being done, we will say they are optically active. So what idea we are going to get? That all optically active isomers are always optical isomers, but all optical isomers need not to be optically active, and this is assertion reasoning based. So what idea we are going to get, kids? Are you able to draw any idea about it? Yes, we are going to understand statement. What statement from this we got? That all optically active isomers are optical isomers. All optically active isomers are always optical isomers. But all optical isomers are not optically active. So it may come in your assertion and reasoning. Kids, agreed or not? Everyone, are you agreed with this point or not? Yes, and one more thing, let me tell you. Let me tell you one more thing. See, kids, suppose if God has given me hand like this, without thumb, and all the fingers equal. Now let me know, there is no thumb and all the four fingers are suppose equal. Now let me know, is there any plane of symmetry? Yes. If you divide it from the middle vertical plane of symmetry, then both the hands will be same. They will be identical. Then we cannot distinguish between right hand and left hand, because they would be definitely identical, and they will be, yes, they will be superimposable. That means if a compound is having plane of symmetry, let me tell you this thing over here. Now see what I am telling you. First of all, let me tell you, if this is being meso, just see to it. If this is being meso compound, everyone see to it. OH, COOH. This question must be coming to your brain, that this is being meso compound. Why this is being meso compound? Although it is having two chiral carbons, then you will come to know that this is meso. This is being meso because of plane of symmetry. Plane of symmetry is there in this compound. This is being plane of symmetry is over here. Now, if you draw the mirror image of meso compound, if you draw the mirror image of meso compound, let's see to it. If I draw the mirror image of meso compound, it will also be meso only. The mirror image of meso definitely will always be meso. Now, once the plane of symmetry is there, once the plane of symmetry is there, kids, this is the plane of symmetry in this compound. This is meso, that is meso, both are being meso. So mirror image of meso is always meso, and they are not enantiomer because these two mirror images are superimposable. These two mirror images are what? Superimposable. And why they are superimposable? Very clear, they are superimposable because they are having plane of symmetry. So these two mirror images are impossible. So they are not different because this was having plane of symmetry, this is also having plane of symmetry because of mirror image. So these are superimposable mirror images. What will you say? They are identical. They are not different. They are being identical. So they will be counted as one only. Identical, or we can say homomorphous. So they are counted as one because they are identical. So they are not different. So identical, one. So we can understand if any compound, why it is known as meso, why it is called as meso. So if any compound, so if any compound is having pos or cos along with chiral carbons, So if any compound is having pos or cos along with chiral carbons, they are known as meso. They are meso. Everyone got it? So that's why in the beginning I've told you that chiral carbon is not the necessary condition. What is the necessary condition? Necessary condition is that the compound should not have plane of symmetry or center of symmetry. Everyone is able to understand? Everyone? Kids, do let me know. So tartaric acid, whenever we talk about tartaric acid is having 3 optical isomers. So what are these 3 optical isomers? Whenever the question is being asked, so tartaric acid, what will you write? Tartaric acid is having 3 optical isomers. How 3? Anyone is asking how 3? 2 plus 1. 2 plus 1. What are these 2 plus 1? What is this thing 2 plus 1? Oh, sir. 2 being optically active. 2 being optically active. Oh, 2 being optically active. Do they have name? Yeah, sir. One is being dextro. One is being levo. Oh, great. And what is this one? So this is being optically inactive. This is named as meso. Oh, these are the names: dextrotartaric acid, levotartaric acid, and mesotartaric acid. Everyone is able to understand? Everyone? No epimer right now. They are not epimers. Kids, they are not epimers. Dextrotartaric acid, dextrotartaric acid, levotartaric, mesotartaric acid, mesotartaric. Everyone, Try to understand. Try to understand. Have you got it? Everyone is able to understand. Yeah, I will tell you Epimus also. Don't worry, I will let you know. I will let you know. So, are you tired or not, or full on Josh? Do let me know. Show me in the chat section. Chat section. How's the energy level, everyone? I wanna see. I wanna see your energy level right now. How is the Josh? How is the energy level? Everyone, show me how is the Josh? How is the energy level? That's really fantastic. Now see, if the compound is having odd number, then that is really awesome. That has been asked twice in AIMS. Two times that question has been asked in AIMS. Let me deal with that question. That is really awesome. See, so I'm going to deal with case number 2. I'm going to deal with what? I'm going to deal with case number 2. Case number 2. Case number 2. Sub case B. Everyone ready? Case number 2, sub case B. Case number 2. Case number 2. Sub case B. This is rank deciding top 50 rank. Rank deciding top 50 rank. Otherwise, you can leave it if you don't want top 50 rank. Now see, I'm going to write one compound. Just try to understand. COOH. CHOH. See, this is a question which has been asked in AIMS. I'm writing the same question. Exactly same question I'm writing. COOH, because in the examination no one will be there to let you know that it belongs to case 1 or case 2. You will be there only with your brain just to decide whether it belongs to case 1 or case 2. Do let me know, everyone, in front of you. Here is the case, here's the question. Everyone, do let me know this belongs to case number 1 or case number 2. Just try to find out what I have told you. Just see from extreme right and extreme left. If from extreme right and extreme left hand side, you are going to get same picture. If you start moving, oh, COH, I have seen COH, then CHOH, then CHOH. And if I move from left hand side, COOH, CHOH, CHOH, oh my God. So I'm getting the same picture from both the sides. That means it belongs to case number 2. This belongs to case number 2. Kids, do let me know that this belongs to case number 2. Are you getting it or not? Because no one is going to tell you over there. Now, how many chiral carbons it is having? How many chiral carbons? It is having one chiral carbon. This is being one chiral carbon and this is being second chiral carbon. These two are being the chiral carbons. Chiral carbon. This is also being chiral carbon. But kids, there's one thing very special. This carbon is known as pseudochiral. What is that? Pseudochiral. Have you heard this name, pseudochiral? Have you ever heard this name? Or we can say prochiral, pseudochiral or prochiral. Have you ever heard this name, kids? Case 1? Yashir made it. It's not case 1, case 2. Yashir made it case 2 because there is symmetry. Whatever we are getting from the right hand side, same thing we are getting from the left hand side. So it belongs to case number 2. Pseudochiral or prochiral. Everyone ready? Now, if you don't want to go in detail, if you don't want to spend your too much brain, then just remember one thing. I'm telling you, just remember one thing. What's that? This type of compound will have two optically active isomers, and two meso isomers. So plus 2, how many optical isomers will be there? How many optical isomers? 2 plus 2, definitely 4 optical isomers. 4 optical isomers. That's it. Just cram it and you will get full marks. And those who don't want to cram it, those who want to understand it, let me know by showing thumbs up that yes, we want to understand it. Then I will make all these 4 and I will definitely let you visualize it. Everyone, do let me know, are you interested to visualize it? What are these 4 isomers? What are these 4 optical isomers? If yes, do let me know in the chat section by showing me thumbs up. Now see everyone. Now it's not necessary that the same example is going to be asked. The example could be like this. See everyone. The example can be given like this. CH3, CHBr, 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 CH3. The example can be given like this. CH3, CHBr, CH, the center one common, Cl, CH, Br. Just try to understand what I am going to teach you. CH3. The example can be given like this. CH3, CH, OH, CH, OH, CH, OH, CH3. Are you able to understand what I am going to tell you? The example can be given like this also. COH, CH, OH, CH, Br, CH, OH, COH. So all they will have same answer. Number of examples I have written, all their answer will be same. I have written first compound, I have written second compound, third compound, fourth compound. All these compounds will have same thing. This is chiral, that is chiral. The center one is being pseudo chiral. The center one is being pseudo chiral. Everyone, now let me tell you how. See everyone, if I make this compound, just try to understand. COOH, CHOH, COH, COH, H, H and COOH. Now just see, this compound is not having any plane of symmetry, no plane of symmetry, and this compound is having chiral carbon, chiral carbon and chiral carbon. 3 chiral carbons are there. All 3 are being chiral. Now you will say, sir, in the starting you said it is pseudo chiral in the middle one. The middle one is being pseudo chiral, but right now you're saying it is being chiral. What is this? I will let you know. Just try it. Have patience. My patience is burning. Is this entertaining? Like that? So, thank you, Deepthi. Thank you, Deepthi. Now see, all 3 are being chiral. This is being chiral, this is being chiral, and this is also being chiral. Now, if I place mirror over here, or we can say water image, you know water image. So, water image, just try to understand water image. Mirror downside, or the river image, or the ocean image. Ocean, they do not form images. So, see, what are you going to get? H, H, OH, COOH, COOH, and now OH, OH and H. These 2 are non-superimposable mirror images of each other. So what relationship they are having? They are not having plane of symmetry, no plane of symmetry. So this is also chiral carbon, this is also chiral, this is also being chiral. So no plane of symmetry. Plane of symmetry is missing. Plane of symmetry is missing. So they are being enantiomeric pair. These 2 are being enantiomeric pair. Let us give the number A and B. So A and B are enantiomeric pairs, right? and optically active definitely in isomeric pairs. So optically active. Now these two are optically active, they are not having plane of symmetry. Now let me draw a compound like this. See, OH, 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 COOH, COOH, H, H, H. Now see, from where the plane of symmetry is moving, from where we should divide it, we should cut it, imaginary plane, so that I can say like, yes, it is involving plane of symmetry, kids. So if I draw one line from here, you can see this is dividing the whole compound in two equal parts. Can you see, everyone? Just to let me know. Can you see? This is dividing the whole compound in two equal parts. Everyone, just to let me know. So this is plane of symmetry. This is being plane of symmetry. So plane of symmetry is there. This is being meso. Now, if I see this compound in the mirror, its mirror image, if I see this compound in the mirror, its mirror image, let us say this is being C, then C dash, its mirror image will be meso. That will also be meso, right? So meso and meso, C and C dash, what's the relationship between C and C dash? They are being identical. They will be identical, isn't it? They will be identical. So they will be counted as only one. They will be counted as only one. Now, where is the second one, meso? From where you are going to get the second one, meso? Because I've told you in the starting two meso. Now see. Everyone try to see to it. If I draw a compound like this, everyone see to it. OH, OH, H, OH, H, H, COOH and COOH. Now kids, do let me know, is this compound is same as C or different? Is this compound same as C or different? So definitely the answer will come different. Why difference? What's the difference? Everyone see the difference. There all the three OH groups were upper side, or its mirror image lower side, all the three on same side, but here two OH are one side and one OH being different side, but still the plane of symmetry is existing over here. What do you think? Plane of symmetry is present or not? Do let me know that plane of symmetry is being present or not, kids. Do let me know, everyone. Is plane of symmetry present or not? In this compound, what do you say? What do you say that plane of symmetry is being present or not? Do let me know, everyone. The plane of symmetry is present or not? Answer is yes. The plane of symmetry is being present. You can see very well that the plane of symmetry is present. This is your plane of symmetry. You can say this is your plane of symmetry. Can you see? Can you see the plane of symmetry? Everyone, do let me know. This is plane of symmetry. Now, in these two compounds, this is meso, this is also meso. Are the two mesos same or different? This meso and this meso are same or different? Definitely this meso is different from that meso, and it will form mirror image D dash. This D and D dash, definitely they will be identical. These two will be identical, but these two meso are being different. Now the most important point, that this compound is chiral and this carbon is chiral. Both are being chiral, but this is not chiral. Now you will say, sir, what are you telling? What is saying, sir? We are not able to understand. What's going on? Just see. See, this is the twist. You must be finding out, you must be searching or must be waiting for where is pseudo-chiral, sir. What happened to you? In the starting, you were talking about pseudo-chiral, pro-chiral. Now, all the four cases you have discussed, now, not even taking the name of pseudo-chiral, what happened to you? What are you talking about, sir? See, kids, these three are chiral. These three are chiral. But here, this is chiral, this is chiral. Center one is not being chiral, not chiral, because plane of symmetry is here. This is chiral, this is chiral, this is not chiral. It is just like if in your school you are having three friends from class 1 to 3, three friends A, B, C or X, Y, Z. X, Y, Z, all the three friends were really friend. They were real friend, just like a friend in need is friend indeed. But once if you have gone to medical college, X and Z, their nature is remaining same. But Y, the friend Y got turned, U-turn, he has taken U-turn or she has taken U-turn, just she or he has become enemy of you. During the school time, you were having three friends X, Y, Z. But once if you have reached to MBBS college, your Y friend XZ nature is same as when you were in the school. But when you have gone to the college, Y, the friend Y's nature or her nature got changed. He has become or she has become enemy. So when you are going to write down the history, what will you say about this Y friend? When the school time, Y friend was friend, close friend. But once you have entered to MBBS college, he was not friend, he was enemy. So whenever you are going to write history, you will say one of friend was pseudo friend. Which friend? If you don't want to explain to anyone, you want to just tell him or her in short, you will say one of my friend was pseudo friend in the history. That Y friend is acting as pseudo friend. So in two compounds, this friend has acted as chiral carbon, but in these two compounds, this friend has acted as not chiral. So if I talk in the condensed formula, I will say this friend is being pseudo friend. Everyone is able to understand or not? Selva Kumar, Srinath, Killer Science, everyone do let me know that you are able to understand or not. You got it or not? Everyone, do let me know, kids. Do let me know. Everyone. Yes. Now I'm going to tell you difference between epimer, anomer, diastereomer. Wow, Selva Kumar, this example was really awesome. This example is really awesome. And all these examples, I'm taking out time to give you all these examples. I'm always dealing with such type of cases. I want to compare the chemistry with the environment, with human beings, so that you can easily understand it. Anyways, let me tell you, kids, see. But right now, I'm not going to tell you about anomers, epimers and all, because one thing is left. What is that? R and S configuration in flying wedge test formula, because we have to move one by one. Otherwise, we will get distracted or diverted from our path, right? First, we were talking about types of configuration. Let me complete R and S configuration, then 3O, Ri3O, capital D, capital L. So one by one, let me tell you each and everything. Thank you, Yashirmi. Thank you. Now see. So R and S configuration in flying wedge and dash formula. So we are going to deal with R and S configuration in flying wedge dash formula. In flying wedge dash formula. Now, what is this flying wedge and dash formula? Let me tell you, kids. Let me explain it. If I take these four atoms, and this is being carbon, chiral carbon, and if I say that this is one V, just see tetrahedral. If you want to visualize tetrahedral, always make one V, V for victory, and this is another V. This is your tetrahedral. So, once I have told you that Fisher has seen this compound like this, that two valencies are coming towards observer side and two are being going away from observer. That two valencies are coming towards observer side and two are going away from observer. Now, if the same structure is seen by some monkey sitting on the tree, what the monkey will say, yeah, two valencies are coming towards monkey side and two are going downside. Now, this same compound, now if you visualize, just see, everyone, can you see? See, everyone. One valence is this green one is coming towards observer side, the same compound. Compound is same, compound has not got changed. Only one valence is coming towards observer side. You are being the observer, just try to see that this valence is coming towards observer side. Can you see the green one? This is coming towards observer side. And the black one, this is going away from observer. Can you see, kids? This black one is going away from observer. Can you see? And two are just in the plane of paper. If I say this is the plane of board, one valence is coming towards observer side, this green one is coming towards observer side, the black one is going away from observer, and these two, brown and blue, they are in the plane of paper. Now, this is flying wedge direction formula. Fisher has seen two valencies coming towards observer side and two are going away from observer. But flying wedge dash sees compound like this, that one is coming towards observer side, this is being wedge, one is going away from observer, this is being dash, and two in the pop means plane of paper. Everyone is able to understand. Now, if I draw flying wedge dash formula, let me write down. See, if I draw it like this is being your chiral carbon. One valence is coming towards observer side. It will look like this. See, it will look like this, bold. It will look like bold. Can you see? It will look like bold because it is coming towards observer side. Something coming towards observer side, you can see it dark, clear, bigger. Let us say this is one valency, that is X is coming towards observer side and one is going away from observer dash, means you can't be able to see it properly. This is going away from observer and two valencies are in the plane of paper, Can you see? This is X, Y, Z and M. So what picture we can withdraw from this? We can talk about that this is being wedge, non-wedge, not wedge. Wedge means coming towards observer side, coming towards observer. Everyone, are you able to understand? Coming towards observer. This is being dash. Dash means it's going away from observer. Dash is going away, dash, away from observer, and these two are pop means plane of paper, these are in the plane of paper, everyone, pop. So this carbon is being chiral. Now, if such type of structure has been provided in the examination and they are asking, just try to find out whether it is being R or S. So we have to understand the rules and regulations. Selva Kumar saying, I wonder why the views are less. HSP War deserves 1 million views of his pure dedication. Yes, kids, but don't worry. Let's move ahead with our true soul with our 100% efforts. Day will come when hundred thousands, millions of views will be there. But let's keep on trying without any deviation. This is the thing, whenever you are not getting that result for which you are deserving, but then also that is the time your efforts should not be less, your efforts should be 100%. A day will definitely come, your process should have that much of dedication, your process must involve that dedication, that day has to come. So you should have to have that much of efforts, dedication, perseverance, consistency, each and everything, isn't it? So don't worry, kids, don't worry. Definitely a day will come. We shall overcome. We shall overcome one day. My heart says, see. Yeah, deep in my heart. Now, see, this is flying wedge and dash formula. Now, just to understand its configuration, RNS configuration, we have to understand some rules. 3 rules. Are you ready for that rule? Or should I let you know one thing? No need to understand rules. I will let you know how to convert this compound into Fisher. So if I let you know how to convert flying wedge dash into Fisher, then we know very well the Fisher projection, so we know very well. So let's understand how to convert flying wedge dash into Fisher. So kids, rules for converting flying wedge dash to Fisher. It's very simple. Let me tell you, it's very simple. It's not tough. It's not tough. It's very simple. See, rule number 1. First of all, let me draw some compound. Let me write down, here is carbon. Here is carbon. Here is iodine. Here is bromine. Here is hydrogen. Here is chlorine, right? So let me explain. This is being Fisher and that is being flying wedge dash. First of all, we have to understand this is being flying wedge dash. And this is being Fisher. Now, first rule, whatever the atom is attached, atom or group attached to dash line, do remember, any atom or group which is attached to dash line, just put it on vertical line. Put it on vertical line. Rule number 1. Let me write down. Rule number 1. Any atom or group attached to dash line, keep it on vertical line, either at top or at bottom. At top or at bottom, that's your choice. At top or bottom, that's your choice. That's your choice. This is the rule number 1. Are you able to understand? Can you see what I have written? So this bromine is on dash line. I kept this bromine over here. I kept bromine over here. This much you can understand. Everyone do let me know. Can you understand this much? So this bromine was attached on dash line. I have kept over there. Now keep all rest of other atoms as such. Keep rest of other atoms as such. No worries, nothing to do anything else. Hydrogen is over here. I kept hydrogen over here. Chlorine is over here. I kept chlorine over here. Now iodine is over here. There is no place, so iodine I have kept at this place. Everyone able to understand? Are you able to understand? Just take care of atom which is attached to the dash line. You have to keep it on the vertical line. Rest of atoms as such. Rest of atoms as such. You got it? So what is the configuration of this compound? Do let me know. What is the configuration of this compound? 1, 2. Arrow is moving. 1, 2. Arrow is moving, kids. You can see arrow is going anti-clockwise. And least priority group is over here. So what are you going to say? What will you say, kids? LPG is on horizontal line, anti-clockwise. Arrange, sir. R configuration. So this is also R configuration. Everyone able to understand? This one is also R configuration. So everyone is able to understand how to convert flying wedge dash into fissure. Let me give you one example. Now you will say, sir, what is happening if I keep this over here or this over there? What is going to happen? Now let me tell you some special rules so that you will get more confidence. Kids, are you ready for a special case? Special case, they are going to boost your intelligence. See, special cases. Then you can do in the air. You can do this compound in the air. No rule is required. You can do in the air. Special 3 cases. 3 special cases by which configuration of the compound does not change. Configuration of compound doesn't change. Configuration of compound does not change. If you are able to understand this thing, these 3 special cases by which configuration of the compound is not going to get changed, then definitely your life is going to become like wow life. So is everyone ready? Let me drink water. Keep yourself hydrated, everyone keep yourself hydrated. So are you ready? Do let me know that is so we are ready. Kids, do let me know. Is everyone ready? Say yes. How's the Josh? Now see. 3 special cases by which configuration of compound does not change. So case number 1, see to it. Case number 1. By rotating the whole compound by 360 in the plane of paper. 360, so it's simple. How it is going to get changed? It will come over there only, right? By rotating the whole compound by 180 degree, configuration of the compound will not change. Now you will say, sir, prove it. Everyone needs proof, isn't it? So just prove it. By simply writing, we are not going to follow. Just explain it. So kids, see, if I write down this compound I I Br ClH. What is the configuration of this compound? Do let me know what's the configuration of this compound. Number 1, number 2, number 3, number 4, LPG. Now you must have become pro of it. So arrow is going clockwise direction. Now LPG is on vertical line clockwise. VC. What should I write? VC. Yes, what should I write? VC. Everyone do let me know. VC. Complete it. Oh my god, you are taking this much of time. VC. What should I write? Very clear road. Where is killer science? Killer science is there or not? I don't think clear science is there. Otherwise, I must have got the answer. Oh, clear science is there. Now, what I said, you took too much time, clear science. Why? This is the made by you only. Now, very clear road. Now, if I am rotating the whole compound by 180 degrees, see, 180 degree, if I am going to rotate, this will come east, will become west, west will become east, north will become south, south will become da da da. Shoo, shoo, shoo. Now, see, just try to understand who is going to what. H, B, R, I, C, L. Now, find out what's the answer. Number 1, number 2, number 3. Arrow is going clockwise. LPG is on vertical line. So, vertical line clockwise R. This is also R configuration. So, see kids, what I have told you, by rotating the whole compound by 180 degree, the configuration is not going to get changed. Now, what does it indicate? It indicates that if you rotate the compound by 90 degree, then R will become S and S will become R. They will be the enantiomeric pair. If you rotate the whole compound by 180 degree, they will remain identical. So, what's the relationship in between this compound and that compound? If anyone is going to ask, what is the relationship in between these two compounds? So definitely these two compounds are identical. They are homomers. They are neither diastereomer nor enantiomer. So this was the first compound. If you rotate the whole compound by 180 degree, configuration is not going to get changed. Kids, everyone is able to understand? Oh, sleepy mood. Oh my god, clear science. So I think it's going to be 11. Kids, do let me know. Let me tell you some points. Then I think I have to take the one more lecture for optical isomerism because it's a very big topic. So let me tell you these rules, 3 rules, then I will end this class. Okay, kids, do let me know. Oh my god, so less likes. You're not liking the lecture. Smash the like button. If I'm not saying anything, then you are also not hitting the likes. Hit the like buttons. Sir, in previous slide you gave chlorine as LPG. No, no, no. Let me see. Shiv Kumar, chlorine can't be the LPG. Let me check it out. Chlorine can't be LPG. Wait. Oh, sorry. See. Oh, yes. I think it gone wrong. See, it got wrong. Yes. Thank you. Shiva Kumar. Yes. See, by chance to LPG chlorine I have written. Sorry. So chlorine is not LPG, hydrogen is LPG. I take my stylus back, I take my words back. See kids, it's wrong. How chlorine can be LPG? Shiva Kumar, thank you. See, it's a slip of stylus, slip of marker. Hydrogen is LPG, kids. Hydrogen is being LPG, chlorine can't be the LPG, so I think the configuration will get changed. Configuration will also get changed because hydrogen is LPG. So let me see to it, everyone. LPG is hydrogen because this is having least atomic number, one atomic number, right? So arrow was going anti-clockwise, right? So let me write down arrow was going this hydrogen is least priority group is on vertical line, arrow is going anti-clockwise. So VA, just complete it everyone, and Shivakumar, thank you. VA, what should I write? VA, very awesome subject, very awesome subject. So it is S configuration. See kids, S. So by chance here I have written the least priority group, that was by chance. So this is S configuration, S configuration, right kids, right everyone, right? So see, just a little slip of marker that I have written here LPG at place of chlorine, hydrogen is the LPG. Kids, just show me the thumbs up so that I can understand that is you have rectified the this problem or doubt or the misprinting or error, whatever you want to say, you can say. You got it everyone now. And thank you Shiva Kumar for reminding me. So everyone, till now special case number 2. Let's deal with case number 2. Case number 2. Not special, process number 2, better to say, not the case. These are the processes. So in place of case, let me write down process, better to write, otherwise we will get confused. So let me write down here process number 1, process number 2. This is process, because we are just changing to process number 1 and here the process number 2. Process number 2. Now, process number 2, by making even number of exchanges, this you must have studied somewhere. By making even number of exchanges, just see, by making even number of exchanges, configuration will not get changed. Configuration once again will not get changed. Now see, the same case I am taking, iodine, bromine, Cl, hydrogen. Its configuration, so we know very well that arrow was moving clockwise and least priority group on vertical line, LPG. So we stay very clear road, our configuration. Now how to do it, even number of exchanges, just see to it. Let me draw the plus sign, Fisher projection. Okay, now see, if I am exchanging this with this is one exchange, then I am supposed to exchange this with this. What I will get? Hydrogen over here, chlorine at this place, iodine at this place, and bromine at this place. Now some kids must be thinking, so why you have exchanged these and these only? You can do like this also. You could have done like that. Okay, let me take one more example. In that, let me exchange this with this, bromine and Cl. Okay, bromine with Cl, then this is one exchange. Then I'm supposed to exchange this with this, bromine Cl, bromine at this place, Cl at this place, and hydrogen at this place, and iodine at this place. If all the three are not having same configuration, if all the three configuration are not coming same, that means I have done something wrong. I'm teaching you wrong. Okay, so let's see, this is also my examination, or you can say whatever the thing, right? Let's check it out. Kids, So you see to it, if I say this is number 1, this is number 2, arrow is moving like this, and this is being anti-clockwise, clockwise, anti-clockwise, and least priority group is over here. So horizontal, anti-clockwise, arrange sir, R configuration. So we got R. This was R. This was R. Yes, R configuration. That is also R. Now let me check it over here. 1, 2, 3. Arrow is moving. This is clockwise or anti-clockwise? Anti-clockwise, anti-clockwise, and least priority group is over here. You can say HAR. Arrange sir, R configuration. Everyone is able to understand or not? Do let me know, kids. From all the ways it is coming same. I've told you why moving it 180-degree configuration is not getting changed. By making even number of exchanges, configuration is not getting changed. Now, mind-blowing third process I am going to let you know. See, that is really mind-blowing, and that will blow your mind. Blow your mind. Now see, and this is HAR, Harin sir, and blah blah blah. Very clear road. Thanks once again to Killer Science that he is really helping a lot. He is full energetic student, and rest of other students are also very energetic. But today, definitely he has helped a lot. So in today's session, he holds a hell lot of weightage. Yeah, isn't it? So now see, process number 3. Process number 3. By holding anyone, process number 3 says, by holding anyone and rotating other 3, what is this? By holding anyone and rotating other 3, configuration will not get changed. Configuration will not get changed. Now how to hold and how to rotate, that is the super awesome thing. By holding anyone and rotating other 3, clockwise or anti-clockwise. So answer is either clockwise or anti-clockwise. Clockwise or anti-clockwise. This is really awesome. If you are able to understand this, then you can do all the questions within fraction of seconds. This is really going to change your life. Now see, let me write down the same compound. The same compound is like this: IBr CLH. Now kids, I will ask to you only, and you are the one who is going to tell me to which compound should I hold and which compound should I rotate. Everyone is going to get chance. So I will ask to 3 students. Okay, I will make 3 compounds. I'm going to make 3 compounds. Don't worry, everyone is going to get chance. One compound, second compound, third compound. So everyone is going to get chance. Gets at least 3 compounds I have written. First chance I am going to give Killer Science. Killer Science, you got the first chance. The first compound, just let me know out of these 4, which atom should I hold? You got the first chance. Hold. Which atom should I hold? Let me write down 1, 2, 3. The arrow is going clockwise, and this was vertical, clockwise. VCR, very clear road, R configuration. So do let me know. Hold bromine. So hold bromine. Bromine is on hold. So bromine will remain over here, right? Because bromine is on hold. So other atoms, should I rotate clockwise or anti-clockwise? Do let me know. Killer Science, do let me know. Should I rotate other atoms clockwise or anti-clockwise? Clockwise or anti-clockwise? I have holded bromine. Other atoms, should I rotate clockwise or anti-clockwise? Anti-clockwise. See, and rotate anti-clockwise. Now, if I am rotating anti-clockwise, you want chlorine on the east position or south. By rotating chlorine, you want to make chlorine should come on the west position or south position. You want chlorine to come on the west position or south position. Do let me know where you want this chlorine should come. Do let me know. Anti-clockwise, I'm going to rotate it anti-clockwise. You want that this chlorine should come on the west position or the south position. South. Okay. Once I am rotating this chlorine, definitely in front of chlorine, this is on hold. Iodine must be moving and then hydrogen must be moving. So chlorine he wants at the south position. So chlorine has come over here just in front of chlorine, iodine. So ahead of chlorine, iodine, and just in front of iodine, hydrogen is moving. Kids, you are able to understand? Are you able to understand how I have rotated? So suppose if I am rotating, this is I'm holding the stylus and there the remote. If I'm rotating like this, so it will move like this. If the stylus is moving, my head is moving, this remote must be moving, and if I'm moving like this, so everything must be moving in the same direction, and whatever they must be following each other. Now see kids, let's see what is the configuration of this compound. Configuration of this compound, number 1 to iodine, number 2 bromine, and arrow is going which direction? This is anti-clockwise direction, and this is over here. LPG is on horizontal line, HAR, arrange sir, RC, BCR and HAR. We have got R configuration. Now second chance is given to Vidhajanani. You want to hold which atom? Vidhajanani, just to let me know, you want to hold which atom? Fast. Vidhajanani, you want to hold which atom? Do let me know which atom you want to hold. Which atom you want to hold? Chlorine. So chlorine is on hold. So hold chlorine. So chlorine. Now rest of other atoms you want to rotate in clockwise direction or anti-clockwise direction. Rotate clockwise direction or anti-clockwise direction. Which direction you want? Which direction? Clockwise. So you want to rotate clockwise. So if you are rotating clockwise, this bromine you want at south or this bromine you want at west position. So while moving bromine you want at south position or at west position. Do let me know where you want this bromine. Bromine should come to the south position or west. Okay. So I'm moving bromine. This is on hold. Bromine, once the bromine is coming over there, this ahead of bromine is hydrogen will come over here, and this iodine will come over here, right? One position. So iodine will come over here. Now let's find out what is the configuration of this compound. Just see, number 1 this, number 2 this. So 1 to 2 I cannot come like this, I should come like this, because while coming from 1 to 2 we cannot cross the third highest priority group. We can cross only LPG. This point I have told you. So this arrow is moving anti-clockwise. You can see anti-clockwise, and this is LPG, horizontal anti-clockwise. Harendra, R configuration. So you got the same answer, kids. You got the same answer. Everyone. Now is there anyone who want to rotate? Who want to rotate it? Is there anyone? Now anyone want to rotate it? So is there anyone? So everyone got it, kids. So this is your homework. You can do it yourself. So now the toughest question based on this I'm going to give you, and then I will end this class. Otherwise, because we are not able to complete it in one lecture, I will take second lecture of optical isomerism. So let me give you that question which has been asked. In AIMS. So see what question has been asked. See, this question was asked find out the relation C. This is being A compound, one is being B compound. Everyone see to it. A and B. This is being your A compound. This is being your B compound. So the question was A and B are first option enantiomers, second option diisomers, C option identical, D option none. What's the answer? Everyone do let me know. What's the answer? Killer Science is going for C. I'm waiting for rest of others what answer they are going to give. Just let me know. Shiva Kumar is saying, sir, let me try the previous slide, last case. Okay. Shiva Kumar, after this question, definitely I will move to that. Don't worry. Definitely I will move to that. But first of all, because everyone is indulged in this question, let's complete this question, and definitely after completing this question, getting the answer of this question, we will move back. B. Some are going for B, some are going for C. So, kids, you want to do it fast or you want to move slowly, just like tortoise? You want to move like rabbit fast or you want to move like tortoise? Which way would you like to move? Do let me know, then I will let you know the answer, kids. Fast. See. Rotate it by 180 degree. Rotating by 180 degree. Rotate it by 180 degree. Rotation by 180 degree. See, when you are going to rotate it by 180 degree, this will go up. Just in front of this, bromine will come in front of this, chlorine will come in front of this. Configuration will not get changed. This is the answer. Do the rotation by 180 degree, configuration will not change. Now, those who don't know this rule, they will do by RS system. They will do it by RS system. Now, the one who is going to do it, the one who is going to deal with RS system, see how they are getting failed. Just do let me know what is the configuration of this chiral carbon, red carbon. Everyone try to find out what is the configuration of this red carbon, and do let me know what is the configuration of this red carbon. Let me check it out. How many of you are getting failed? How many of you are going to get fail over here? Let me know the red carbon's configuration. I'm waiting for your answer. Definitely 40 to 50% kids will get wrong answer. I'm waiting for your answer, everyone. Do let me know. Kids, yes, do let me know what's the answer. You're taking too much time. Quick, quick. R. Vidhajanani is getting R. Let me check it out. First 5 students answer. What answer they are going to get? R. Killer Science is getting R. 2 students, they have got the same answer, R. R. Rajkumar is getting R. 3 students, they have got R. Four students got R. Let me see one more student. I'm waiting for one more answer. Okay, so 4 answers I've got. Now check. Everyone check whether your answer is being right or wrong. Are you damn sure that your answer is right? See, check it out. Everyone say to it. Definitely this carbon is attached with chlorine, so chlorine will get number 1. Now this C, this is carbon and the lower one is also carbon, so there is tie. This is definitely LPG group. So in between these two carbons there is tie. This is carbon, this is also carbon. Now its highest atomic number oxygen, and its highest group is bromine. Who is senior? Who is having more atomic number? Do let me know. This oxygen is going to be have more atomic number of bromine. Kids, do let me know. These two carbons there is tie because this red one is attached with 1, 2, 3, 4. These are the 4 atoms. This is LPG, this is senior, this carbon and this carbon there is tie. Who is going? Bromine is going to get number 2. So once the bromine has got number 2, kids, so 1 and 2, the arrow is moving which direction? Arrow is moving clockwise direction, and LPG is on horizontal line. H clockwise direction, S configuration. So this carbon is having S configuration. Everyone got failed? Everyone got failed or not? Kids, do let me know that everyone got failed. You have seen COH and you have given number 2 to COH. Never see the group. This is not IUPAC nomenclature, kids. This is not IUPAC nomenclature. This is being your CIP rule. Don't apply IUPAC. Apply, kids. Apply CIP rule, and CIP rule says move atom by atom. Don't see the group. Don't go and see the bigger group. Just move atom by atom. Everyone got failed or not? Yeah, carbon is having double bond, so what? Double bond, although this carbon is attached with 3 oxygen, but we have not to see all the atoms. We have to the senior most one atom. We have to see the senior most one atom, and this is having senior most one atom that is having 3 oxygen, but we are not interested in 3 oxygens. This is decided by bromine only. Once this bromine is the highest atomic number, carbon same, but bromine, it is winner by bromine. Killer Science, you got it or not? Everyone, you got it or not? Everyone got failed. I said only 40 to 50% students are going to get failed, but everyone got failed, kids. Now if you are going to do it by RS system, you won't be able to do it. You won't be able to do it because you are going to take too much time, and even you are doing wrong approach. Everyone, Everyone, you got it? Now let's move. So answer is they are identical. They are being identical. Identical is the correct answer. I hope that everyone is able to understand. Now let's move at the back one, and Shiva Kumar is going to do it. Shiva Kumar, okay, let me know which atom you want to hold. Shiva Kumar, do let me know which atom you want to hold. Fast, do let me know. Shiva Kumar, where is Shiva Kumar? Which atom you want to hold? Hold, which atom you want to hold? Do let me know. Hold. I'm waiting for your answer, Shiva Kumar. Hold iodine. Shiva Kumar holded iodine. Now, rest of other atoms you want to rotate clockwise or anti-clockwise? Clockwise or anti-clockwise? Rest of other atoms you want to rotate clockwise or anti-clockwise? Shiva Kumar. Clockwise. So you want to rotate clockwise. You want to make bromine or chlorine, which position? Either bromine or chlorine. You select either of atoms and which position you want to, they should come and take position, which position you want to make them located. Bromine should come east position or south position. Do let me know where you want this bromine should come, where you want that bromine should come or chlorine should come, whatever the atom you can select, and do let me know where they should come. East, bromine should come at east. Okay, bromine, little bit he has shifted bromine over here, so chlorine over here. Now hydrogen should occupy this position, but already this is being occupied, so hydrogen will come over here. Hydrogen will come and occupy this position. Now see, Shiva Kumar, number 1 I will give to iodine, number 2 to this, and I can move from LPG only. So arrow is moving clockwise. Arrow is moving clockwise. So LPG is on vertical line. Vertical line clockwise. We see very clear road. R configuration R. So Shiva Kumar, are you able to understand? Everyone gets. So everyone got it. Everyone is able to understand it. Do let me know that yes, you are able to understand. You got it. Now, definitely today's session was mind blowing, and really you kids are super awesome that for the continuous 5.5 hours, it's 18 past 11, almost half past 11, you can say 5.5 hours. For the continuous 5.5 hours you are studying, you're watching this lecture. Really awesome, really awesome. I would like to say from the internal core of my heart, really you are dedicated students, hardworking students, and once these kids are really hardworking, your success is waiting, because there is no substitute of hard work. And this not only the hard work, it requires perseverance, it requires persistence, and it requires a high willpower. You know that the kids with high willpower, no obstacle is there, and no obstacle can stop a person with high willpower. You are going to get your aim, you are going to reach your goal. Success is definitely waiting for you, kids. All the best, all the best, all the best, kids. Best of luck. Jai Hind, Vande Matram, all the best. So I was thinking of giving you one question for your homework, but I think it's too late. Already you must be tired. So should I give you one question for your homework? Let me give you one question for your homework. Okay, just one question for your homework. This is your compound. This is cholesterol derivative. You are supposed to find out total number of chiral carbons. This is somewhat you can say cholesterol derivative. This is just for practice. This is just for practice, okay? This is your homework. Let me tell you, this is your homework. Okay, kids. I would like to see the answer in your comment section. Fine. Good night, kids. Really dedicated students, all dedicated students, all future doctors. Really, all the best. Bye. Bye from your HSP Baba. Bye from your Conquer team. I'll be waiting. Yes, definitely in the coming lecture. Okay, bye.